हेलो टेस्ट 1 2 हेलो हेलो टेस्ट कोई बात नहीं, ये लो बढ़ा देते हैं, लो हेलो टेस्ट बढ़ाई बड़ी हेलो टेस्ट। अभी रुको ना, अभी तो ऑन बंद है ना सारा, ये देखो मैं धीरे सारा ऑन कर रहा हूँ। आ गई। हेलो टेस्ट 1 2 हेलो टेस्ट 1 2 हेलो ऑडियो टेस्टिंग 1 2 हेलो टेस्ट 1 2 3 4 5 6 हेलो टेस्ट 1 2 1 2।
And today, in this beautiful morning, we have gathered here to bring about a significant change. Namaste to everybody. My name is Harneet Kaur Gupnani, and I'm more than elated to be joining you all as your host today. Thus, I extend a warm welcome to each one of you, and I also request our distinguished guests to join us on the dais. Starting with respected Shri Bhagwant Khuba, Honorable Minister of State in the Ministry of Chemicals and Fertilizers and New and Renewable Resources, Energy, Government of India, as the chief guest of today's conclave. Can we have a big round of applause for respected sir? Moving forward, I would like to request Mrs. Aarti Ahuja, Secretary, C&PC, Department of Chemicals and Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India, who is present here and took a lead role and continuously guided the team to organize this conclave. Can we have a big round of applause for respected ma'am? Moving forward, I request our senior officials to join us on the dais as well. Can we have a big round of applause for all our senior officials for joining us on the dais? As you all are aware, the CEOs are set up with an aim to help in development of new products, new applications, innovation and improvement of technology, process innovation, quality, environmentally sustainable development, etc. The COEs are also expected to help building brand image of India in exports. Institutions through this project will interact and pass on their research findings, expertise, etc. to the industry for modernization of petrochemical industry, both upstream and downstream. The department till date has approved 13 COEs under the scheme, which are bifurcated as following: bioengineering polymeric systems, polymers-based biomedical devices, advanced polymers and composites, and finally, polymer-based toys. And once again, I request everybody to give a big round of applause for our respected chief guest, following by the respected secretary, Mrs. Aarti Ahuja. I also present my gratitude to Sir for joining us despite his busy schedule, and rest of you also for making to this conclave. Thank you so much, everybody. I also thank representatives from all the centers of excellence, experts, industry associations, and industrialists. So as they say, that before commencing anything auspicious, it is important, it is a mandate to remember the Almighty and seek His blessings. ये हमारी हिंदू संस्कृति में आवश्यक है कि किसी भी शुभ घड़ी से पहले, किसी भी मंगल कार्य से पहले हम ऊपर वाले को याद करें, उस ईश्वर का साथ लें, सर पर हाथ लें, स्नेह भरा साथ लें। और आज की इस कॉन्क्लेव को भी यूं ही आगाज किया जाएगा, दीप उज्जवल करते हुए, ईश्वर का आशीर्वाद लेते हुए। मैं चाहती हूँ आप सभी ढेर सारे स्नेह के साथ इस दीप उज्जवल की ओर बढ़ें। Can we have a big round of applause for the lamp lighting ceremony as I request our respected Honorable Minister and respected Secretary Ma'am, along with all the distinguished guests, to join us for the lamp lighting. As the light from the lamp eradicates the darkness that beholds, just like that, the light from the God, eradicates the negativity that resides और आगे बढ़ने से पहले मैं चाहती हूँ हम गणपति जी को याद करें ओम गणपते नमः के साथ। तो मेरे साथ प्लीज दोहराइए ओम गणपते नमः। Thank you so much once again. Once again, I present my heartfelt gratitude to all our distinguished guests, especially to the chief guest of this conclave and respected secretary. And we cannot be any more thankful, any more grateful to all of you for joining us. Thus, we would like to present a flower bouquet as the warm welcome to all our distinguished guests and, of course, our chief guest for the conclave. I request Dr. Professor Shishir Sinha, Director General, CIPIT, to present a bouquet to respected Shri Bhagwant Khubaji, Honorable Minister of State in the Ministry of Chemicals and Fertilizers and New and Renewable Energy, Government of India. Now, I request Ms. Shubha Jayaraman, Senior Technical Officer, CIPIT, to welcome Mrs. Aarti Ahuja, Secretary C&PC, Department of Chemicals, Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India, by presenting a bouquet. Further, I request Dr. P.S.G. Krishnan, Principal Director, CIPIT, to present a bouquet to Shri Satyendra Singh Ji, Additional Secretary and Financial Advisor, Department of Chemicals and Petrochemicals. Can we have another big round of applause for the same? Once again, I request Dr. P.S.G. Krishnan to welcome Shri N.K. Santoshi Ji, Deputy Director General, Department of Chemicals, Petrochemicals, by presenting a bouquet. And last but definitely not the least, I once again request Dr. Krishnan to welcome Dr. Professor Shishir Sinha, Director General, CIPIT, by presenting him a bouquet as well. Thank you so much, everybody. After taking over charge as Secretary C&PC in the Department of Chemicals and Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India, Mrs. Aarti Ahuja is taking various initiatives, mainly focused in R&D activities, industry connects, etc. Under her mentorship, department and its activities have increased fourfold, resulting in better connectivity among industry and efficient utilization of resources of leading institutes. Fueled by the zeal to bring about a significant change, Ma'am Aarti Ahuja Ji envisioned to organize this conclave as a platform to bring together industry and academia and ensure that commercialization of the research and output happens. I proudly invite Mrs. Aarti Ahuja, Secretary C&PC, Department of Chemicals, Petrochemicals, for delivering welcome address. Can we have a big round of applause for ma'am?
Thank you, Honorable Minister of State, Chemicals and Fertilizers, my colleagues on the dais and colleagues in the audience. First of all, I really do not deserve all the words you have spoken about me. I'm just doing my job, but thank you in any case. It feels nice to hear nonetheless. So coming to today's occasion, sir, the department has been funding centers of excellence, which are normally situated within the academia since a long time. And these centers of excellence are centers of excellence. They have been doing pioneering work, innovation, incubation, developing new technologies, doing new things, which can really help the industry. So we all know that even the biggest of steps, the journey of 1,000 miles begins with one step. And we have seen that repeatedly in different countries. In fact, my industry colleagues will remember the story of Nokia. How with a small innovation, the whole country grew exponentially because of that small thing of a phone that started, a mobile phone that started, and what a revolution it caused. So it is the small innovations that can make a difference. And in India, we are often criticized for our lack of innovation. We are good at following processes and technologies that have been developed elsewhere. Although we have a very good startup ecosystem, we have that whole, in IT and in services, it has grown very well. But in manufacturing somehow, and especially in our sector, we need to understand this gap that exists as far as innovation is concerned, innovation in technology and in products. So that is why we need to bridge this gap between the industry and the academia. This is not the only thing. These 13 centers of excellence are not the only ones doing this. They are the ones that have been funded by the department. Apart from that, there are a number of chemical engineering departments in various IITs, various other universities, etc., that we are going to tap now. And we will try and see how we can do funding, how they can customize their research based on the industry's requirement. So we will also need your support for that. You tell us what kind of innovation, what kind of incubation is needed, what you want to be developed. CPET does that for these small units. They do the industry support through different mechanisms. They do that. Similarly, the other places, other academic institutions can become a huge source for our sector for development, for innovation, for incubation, and for moving ahead. So the ball also lies in the court of the industry now to tell us what you need to be done. So idea is not that any COE should work in isolation. Idea is not to publish papers. Idea is to be useful to the country. Idea is to be useful to the industry and help the country grow, help import substitution of technology, help import substitution of products, intermediates. So let us work on that, because we may keep on doing the same things over and over again. But unless we break that cycle, unless we really get into that mode of working together, of learning from each other, then we will remain in those silos, and the excellent minds in the industry and in the academia will not be able to work together. The time has come now not just to meet in meetings, but to work together with a common purpose. So I'm quite confident that this will be a first step, and we will take this forward with the help of these COEs, with the help of other institutions, with the help of the industry leaders. We will forge a new path ahead, and I wish this conclave all the success. It is, as I said, a first step. It's going to be a continuous process, because excellence cannot be achieved by this one thing. It is a continuous process, and all of us have to achieve that excellence if we have to move forward. I'd like to once again welcome Honorable MOS for being here with us today. Sir, your presence has encouraged everybody in this room, because it sends a signal that at the highest level there is support for bringing academia and industry together. And I also thank all the industry representatives for being here. You are all very busy people. Thank you for taking time out and coming here and listening to what is going to be presented today. I'd like to thank those who coordinated this whole program. Dr. Ghosh is here from IIT Delhi. Mr. Soni is here, and others, all those who worked on this, and all the centers of excellence heads who spearheaded this research, and we are looking forward very eagerly to listen to your presentations. Thank you once again.
First of all, I thank you, respected ma'am, and your humility. It is commendable that how precisely you plan towards executing and working together as a unibody. We are sure that this POA will open doors for new opportunities and new growths. Now, it is our privilege that Honorable Minister of State in the Ministry of Chemicals and Fertilizers and New and Renewable Energy, Government of India, respected Shri Bhagwant Khubaji is here to encourage activities of COEs of the department. His continuous support in this type of conferences, conclave industry needs are boosting the growth of the industry. Can we have a big round of applause for respected sir as I request him to share his opinions.
सभी को मेरा नमस्कार। कॉन्क्लेव ऑन इंडस्ट्री कनेक्ट विथ सेंटर ऑफ एक्सीलेंसी, मंच पर उपस्थित श्रीमती आरती आहूजा जी, श्री सत्येंद्र सिंह जी, प्रोफेसर श्री शशिर सिन्हा जी, श्री NK संतोषी जी, और विशेष करके आज इस महत्वपूर्ण सभा के अंदर देश के जाने माने उद्योग जगत के CEOs और पत्रकार मित्रों, आज की इस बैठक में बहुत छोटी ग्रुप होगा और ये ग्रुप बहुत प्रभावी ग्रुप होगा और इस ग्रुप का प्रभाव देश में और दुनिया में भी उसका प्रभाव से जाना जाएगा। इस छोटे ग्रुप में सरकार के सेंटर ऑफ एक्सीलेंस के साथ उद्योग जगत को कैसे जोड़े, और मैडम ने कहा रहती कि वर्क टुगेदर, मैं इसके साथ में और एक शब्द में जोड़ना चाहता हूं कि वर्क टुगेदर के साथ ग्रो टुगेदर, क्योंकि हम यदि अपने अपने सेल्यूलोज के अंदर यदि अगर हम काम करते रहे, दुनिया का स्पर्धात्मक जगत के अंदर टिकना बड़ी मुश्किल होगा। समझ लीजिए नदी का दो तट पर, एक तट पर विज्ञान के भंडार है, दूसरे तट पर उद्योग जगत की आवश्यकता की पूरी करने की जगत है। यदि अगर ये दोनों तट कर हम नहीं जोड़ पाए तो ये मुश्किल होगा कि कंपटीशन की जगत के अंदर हम पीछे रह जाएंगे। और नॉलेज एक तरफ रहेगा तो उस नॉलेज की उपयोगिता सस्टेनेबिलिटी के साथ, टेक्नो इकोनॉमी के साथ जब हम जोड़ के देखें तो ही हमारा उत्पादन, हमारा प्रोडक्ट इकोनॉमी भी होगा और टेक्निकल साउंड भी होगी। और उद्योग जगत इतना उनके पास न समय रहता है, न इसके ऊपर रिसर्च एंड डेवलपमेंट के ऊपर हर उद्योग को उतना खर्च करने का भी कभी कभी नामुमकिन हो जाती है। लेकिन सरकार के इस मंशा के साथ में हमारा डिपार्टमेंट ऑफ डीसीपीसी और सीपेट आज मोदी जी सरकार आने के बाद आईआईटीज के अंदर और सीएसआई के अंदर अच्छे अच्छे संस्थान के अंदर सेंटर ऑफ एक्सीलेंस स्थापना करके उन सेंटरों के अंदर भारत सरकार उसको स्ट्रेंथन भी कर रही है और उस सेंटर के अंदर अनेक रिसर्च एक्टिविटीज जो देश को चाहिए वो वहां पर निरंतर उसका काम चल रहा है। आज पेट्रोकेमिकल्स बहुत महत्वपूर्ण क्षेत्र है। पेट्रोकेमिकल्स देश का इकोनॉमी ग्रो करने के लिए बहुत उसका योगदान भी रहा है। आज पॉलीमर हर क्षेत्र के अंदर उसका जरूरत पड़ी है, एग्रीकल्चर हो, ऑटोमोटिव हो, स्पेस हो, हेल्थ केयर हो, अनेक क्षेत्र के अंदर पॉलीमर की उपयोगिता बढ़ते जा रही है। तो इस पॉलीमर को लेकर के हमारा सेंटर ऑफ एक्सीलेंस सीपेट जो चलाती है, उन सेंटरों के अंदर अनेक संशोधन हमारा साइंटिस्ट ने किया है। उदाहरण के तौर पर वेस्ट मैनेजमेंट में हमने लिया है, रिसाइकलिंग में हमने लिया है, हेल्थ केयर सेक्टर में हमने किया है। तो ये सारे संशोधन को एक परिप्रेक्ष्य में दे करके हम यदि उन ज्ञान भंडार को लेकर के हमारा इंडस्ट्री और हमारा प्रोडक्ट को किस तरह से लाभ हो सकती है, दोनों साथ साथ मिल करके, दोनों साथ एक कट्टा आकर के, और ये दोनों के लिए भी फायदेमंद होगा क्योंकि हमारा पास नया संशोधन की डाटा है जो इंडस्ट्री को डाटा की जरूरत रहती है। इंडस्ट्री को नया प्रोडक्ट लाने में और कीमत, कास्ट ऑफ प्रोडक्शन कम करने में मदद हो सकती है। ऐसे एक प्लेटफॉर्म पर इंडस्ट्री क्या चाहती है, इंडस्ट्री को क्या जरूरतमंद है, इसके साथ में हमारा संशोधन का ज्ञान भंडार को लेकर के उसमें से जो अपने को मिल सकती है लेकर के यदि हम साथ में काम करें तो अपना देश का उद्योग जगत का प्रोडक्ट अंतर्राष्ट्रीय स्तर पर इकोनॉमिकली एंड क्वालिटेटिवली और टेक्निकली पेश करे, तभी जाकर के हम इंपोर्ट भी कम कर सकते हैं। आत्मनिर्भर बनना केवल हमने प्रोडक्ट बनाया, मार्केट में एक्सेप्ट होना नहीं होना, ये बहुत मायना रखता है। हम सेंटर ऑफ एक्सीलेंस के अंदर यदि हम संशोधन भी किया, अगर वो प्रोडक्ट में रूप में अगर बाहर नहीं आया सेंटर छोड़ करके, तो उसको कोई मीनिंग नहीं रह सकता। आज हजारों पेटेंट्स रजिस्टर हुए हैं, लेकिन इकोनॉमिकली कहीं वायबल नहीं हो सकती है। जब संशोधन ऐसे हो कि डिमांड बेस्ड संशोधन हो, डिमांड बेस्ड होने के बावजूद उसको इकोनॉमिकली वे से भी हम लोग संशोधन करें, ये दोनों साथ साथ में अगर इंडस्ट्री को मिले तो निश्चित रूप से उद्योग जगत इसको स्वागत करेगा और उसको अडॉप्ट भी करेगी। इसके बिना हम यदि नहीं किया और कोई करने वाला है इस दुनिया में, वो आगे चला जाएगी। आज भारत के अंदर मैन पावर का कोई कमी नहीं है। हमारा अनेक सेंटर ऑफ एक्सीलेंस और ट्रेनिंग सेंटरों के ओर से स्किल डेवलपमेंट, स्किल मैन पावर को हम लोग दे रहे हैं। ये सारे चीजें इंडस्ट्री को मदद करने वाले हैं और उस दिशा में भारत सरकार अनेक कदम लेकर के इंडस्ट्री को कैसे वायबल बनाए और विश्व स्तर पर अपना प्रोडक्ट को कैसे पेश करे, यही मकसद के साथ आज का जो कॉन्क्लेव है, इस कॉन्क्लेव के अंदर बहुत ही प्रभाव इंडस्ट्री के सीईओज, ताकि सेलेक्टेड होकर के हमारा डिपार्टमेंट ने बुलाया है, क्योंकि आप लोगों से सरकार अपेक्षा भी करती है कि हमारा सेंटर जैसे ग्रो करते रहे, उसका संशोधन आपका उपयोग में आए और आपका आर्थिक सहाय भी हमारा सेंटर्स को मिले, जो सेल्फ सस्टेनेबिलिटी हो। इसी के लिए यहां पर आज दिन भर आपके साथ टेक्निकल सेशन भी होगा। अच्छे तरह से इंडस्ट्री और विश्व आज कहां खड़ा हुआ है और क्या चाहती है, आज केवल आज के दिन ही नहीं है, भविष्य के लिए भी क्या बदलाव लाना चाहती है। बदलाव की जरूरत तो वो वर्तमान की भी मांग रहेगी और विशेष करके भविष्य के लिए उसका जरूर रहेगी। जैसे जापान का एक शब्द काइजन है, तो निरंतर उसके अंदर बदलाव, गुणवत्ता भी हो, गुणात्मक भी हो, चाहिए, वरना इंडस्ट्री ज्यादा दिन हो या और कोई क्षेत्र बदलाव के बिना उसका भविष्य नहीं हो सकती है। तो भारत सरकार ये चाहती है कि भारत का भविष्य बहुत लंबे से लंबे हो और इंडस्ट्री का भी भविष्य ज्यादा से ज्यादा लंबे हो, क्योंकि हम कभी कभी चर्चा में देखते हैं हम अनेक राष्ट्रों के ऊपर निर्भर हैं। कोविड का महामारी के अंदर वो निर्भरता हमको कितना महंगा पड़ा, हम सब जानते हैं और हम सब उसका अनुभव भी लिया है। तो इसी के लिए माननीय प्रधानमंत्री जी आत्मनिर्भरता की ओर बहुत जोर दिया है। तो पिछला 2 साल के अंदर भारत की उद्योग जगत भी माननीय प्रधानमंत्री जी का आत्मनिर्भरता का स्वागत करके बहुत उसको मदद भी की है। इसी के कारण देश के अंदर वैक्सीनेशन डोज भी उत्पादन हुआ और आज हम बड़ी गर्व से कहते हैं कि भारत वैक्सीनेशन डोज बनाने में भी यशस्वी किया और 1 से 90 करोड़ से ज्यादा डोजेस देने में भी हम लोग यशस्वी हो गए। ऐसे महामारी के अंदर भी एफडीआई हम यदि अगर देखें तो भारत के अंदर काफी एफडीआई भी इस कोरोना महामारी के दौरान भी आते गया। ये दर्शाता है भारत में आज भारत आने वाला स्वतंत्रता का 100 साल यानी आने 25 साल तक निश्चित रूप से 100% तो आत्मनिर्भरता होगी नहीं, लेकिन परावलंबी यानी दूसरों के ऊपर ज्यादा से ज्यादा निर्भरता न हो, इसमें कोई शक नहीं। हमारा उद्योग जगत और भारत के मानव संपन्मूल उस दिशा में यशस्वी रूप से काम करेगी। और आज हमारा कॉन्क्लेव में डिपार्टमेंट डीसीपीसी और हमारा सीपेट बहुत ही महत्वपूर्ण समझ करके कार्यक्रम बहुत अच्छे रूप से रचना की है कि इसमें 1-to-1 नॉलेज शेयरिंग हो, जरूरत है एक को एक शेयरिंग हो, और हमारा सेंटर ऑफ एक्सीलेंसेस कितने काम किया है वो कामों का ब्यौरा भी दे, और इसमें से उद्योग जगत को क्या लाभ हो सकती है। और यदि आपने अगर कुछ सुझाव भी दिया, नहीं हमको इसी एरिया में हमको इनोवेशन करना है और इस प्रोडक्ट को हमको डेवलप करना है, टेक्नो इकोनॉमिकली डेवलप करना है, तो निश्चित रूप से मैं मानता हूं कि हमारा सेंटर ऑफ एक्सेलेंसेस उस दिशा में काम करके दोनों नदी का 2 तट जो मैंने बोला शुरुआत में, उसको आज का कॉन्क्लेव एक सेतु बन के दोनों को जोड़े, और निश्चित रूप में आज का चिंतन मंथन में सभी विचारों का आदान प्रदान होकर के एक अमृत जैसा एक विषय निकल के आए। उस अमृत को सभी ने स्वीकार करके आगे आने वाले दिनों में भारत को हम लोग आत्मनिर्भरता बने। और आज इस कॉन्क्लेव के लिए हमारे बड़े मंत्री जी मनसुख भाई मांडविया जी, उनका दिशा निर्देश के अंदर, और हमारा डीसीपीसी और सीपेट बहुत ही परिश्रम डाल के इस कार्यक्रम को किया है। तो मैं इन सभी को बधाई देते हुए, आप सबको मेरा शुभकामना देते हुए मेरे 2 बात मैं समाप्त करता हूं। धन्यवाद।
सबसे पहले तो मैं सर का तहे दिल से शुक्रिया अदा करना चाहूँगी, तहे दिल से धन्यवाद करना चाहूँगी। आपकी वर्क टुगेदर ग्रो टुगेदर की सोच को जितनी सराहना दी जाए उतनी कम है, और ये निश्चित है कि आपके इन कदमों के साथ आत्मनिर्भर भारत का सपना भी साकार होगा और विश्व में भारत को अपनी एक नई पहचान मिलेगी। Also, we are more than happy that 550 guests are present online as this conclave is being broadcasted live on YouTube. We are also elated that today we are launching the e-newsletter of CIPIT along with the portal for COE and Industry Connect. I request the Sir, respected Honorable Minister, to help us in the same.
Here, sir, so that it can be launched. You can touch here, you can get launched. Yes, let's see you. See you.
फोटो नहीं आया।
Once again, I thank our Honorable Minister from the depths of my heart on behalf of everybody here. CIPIT, established in 1968 in Chennai, has now more than 38 centers across India. The activities of CIPIT in terms of academia, skill development, technical support services, and R&D have increased manifolds. To disseminate the activities of CIPIT, this e-newsletter has been launched, to which have subscribed many industries, associations, our CIPIT alumni, which will be easily available to all the stakeholders online. Further, another initiative, that is the portal for COE and Industry Connect, will help to provide a platform for interaction between industry and COEs. Department today takes pride that our Honorable respected Minister has helped us with the launch of both these initiatives, which will help us shape a better future. Moving on, as we all know, that global warming today is a big problem. Considering the same, we thought that the best gift today to the Mother Nature, to the motherland, and to all our distinguished guests will be planting a tree in the name of our guests and, of course, chief guest. Thus, I request Dr. Professor Shishir Sinha, Director General, CIPIT, to present the Green Certificate to respected Shri Bhagwant Khubaji, Honorable Minister in the Ministry of Chemicals and Fertilizers and New and Renewable Energy, Government of India. Once again, thank you so much, sir. Now, I request Ms. Shubha Jayaraman, Senior Technical Officer, CIPIT, to present Green Certificate to Ms. Aarti Ahuja, Secretary CMPC, Department of Chemicals and Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India. Further, I request Dr. P.S.G. Krishnan, Principal Director, CIPIT, to present the Green Certificate to Shri Satyendra Singh Ji, Additional Secretary and Financial Advisor, Department of Chemicals, Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India. I also request Dr. P.S.G. Krishnan to present the Green Certificate to Shri N.K. Santoshi Ji, Deputy Director General, Department of Chemicals, Petrochemicals, Ministry of Chemicals, Fertilizers, Government of India. And finally, I request Dr. P.S.G. Krishnan to present Green Certificate to Dr. Professor Shishir Sinha Ji, Director General, CIPIT. Once again, I present my gratitude to everybody here, especially to our distinguished guests and our Honorable Minister. Now, I request Dr. Professor Shishir Sinha, Director General, CIPIT, to move ahead with a vote of thanks.
नमस्कार, माननीय मंत्री जी श्री भगवंत खुबा जी, मान्यवर, आपकी उपस्थिति से इस पूरे कार्यक्रम के आयोजन में एक ऐसी जो है प्रेरणा मिली जिससे कि आगे हम लोग जो है भविष्य में इस तरीके के कार्यक्रम को जो है वो आयोजित करें, जिससे कि उद्योग जगत और शोध संस्थान और एकेडमिक संस्थान एक मंच पर आए। और ये इस बात को परिलक्षित करता है कि भारत सरकार शोध को प्रयोगशालाओं से बाहर लाकर उद्योग जगत के सामयिक दृष्टिकोण को रखते हुए किस तरीके से गंभीर है। और मैं आभारी हूँ हमारी सचिव महोदया सुश्री आरती आहूजा जी का, जिन्होंने इस बेसिक कॉन्सेप्ट को जो है वो दिया कि हम लोग जो है किस तरीके से जो है विभिन्न तरीके के जो उत्कृष्टता केंद्र हैं भारत के जो रसायन एवं उर्वरक मंत्रालय ने जो दिए हुए हैं, उनको किस तरीके से उद्योग जगत के साथ सहभागिता करते हुए देश की प्रगति में जो है हम लोग आए। और ये मुझे आशा नहीं वरन पूर्ण विश्वास है कि ये मंच जो हम लोग यहाँ पर दे रहे हैं, उससे जो शोध केंद्र हैं, साथ में उत्कृष्टता केंद्र हैं, एकेडमिक केंद्र हैं, और उद्योग जगत के साथ जाके देश की प्रगति में आत्मनिर्भर भारत की प्रगति में, आत्मनिर्भर भारत के पथ में अग्रसर होंगे। और ये एक आत्मविश्वास देगा हमारे शोध केंद्रों को और उद्योग जगत को कि हम लोग आपस में जो है किस तरीके से जो है सहभागिता रख सकते हैं। मैं आभारी हूं मंचासीन श्री सत्येंद्र सिंह जी का और श्री एनके संतोषी जी का, जिन्होंने जो है इस कार्यक्रम में आके इसकी एक शोभा बढ़ाई। साथ में सबसे ज़्यादा मुझे जो है हर्ष इस बात पर है और मैं आभारी हूं अपने उद्योग जगत का, जिन्होंने बढ़ चढ़कर इस कार्यक्रम में जो है भाग लेकर हमारे जितने भी उत्कृष्टता केंद्र हैं और शोध केंद्र हैं और एकेडमिक स्ट्रक्चर है, उनको जो है वो एक उत्साहवर्धन के लिए किया। मुझे आशा नहीं पूर्ण विश्वास है कि हमारे जो विभाग के जो 13 उत्कृष्टता केंद्र हैं, वो उद्योग जगत की इस उपस्थिति से जरूर लाभान्वित होंगे। और साथ में उद्योग जगत भी ये इस चीज को समझेगा कि हमारे जो उत्कृष्टता शोध केंद्र हैं वो क्या कार्य कर रहे हैं और किस तरीके से कर रहे हैं, और अपने अनुभव जो है उनके साथ शेयर करेगा। सो आप लोगों का बहुत बहुत आभार। मैं विभाग की तरफ से, अपने व्यक्तिगत तरफ ओर से, सिपेट की तरफ से बहुत बहुत आभार व्यक्त करता हूं कि आपकी उपस्थिति से इस जो मंच है, जो ये सतत मंच है, उसको जो है एक शोभा मिली। धन्यवाद।
Once again, I thank Mr. Shishir Sinha ji for his vision and his opinions. And I request all of you ladies and gentlemen to join us outside for the tea break. We will start with the technical session at 11 o'clock. And before taking this break, I would like to wrap up this session by this quote which says, चलो नई मिसाल हो, चलो नई मशाल हो, बड़ो नया कमाल हो, झुके नहीं रुके नहीं, बड़े चलो डटे चलो। तो इसी सोच के साथ हम बढ़े चलेंगे, हम डटे चलेंगे, और आप सभी से मुलाकात होगी पूरे 11 बजे। थैंक यू सो मच।
request everybody to please settle down and we'll start the next session. Now we come to the technical sessions, and the Centers of Excellence are going to present their work. The prime audience is the industry representatives who are present here. So although, you know, what happens is when we have been working very hard in one area and we get an opportunity to present, we do tend to get carried away. It happens to all of us. But my request to all the presenters is to maintain the time of 5 to 7 minutes. So there'll be a first bell at 5 minutes and the second bell at 7 minutes. So let us see, you know, you are all academics and you are all in teaching institutions. So let us see your skills in bringing together the crux into 5 minutes. This is also a test of that. So I will request somebody from the audience to please maintain the time. Who can do it? One of the girls here? 5 minutes, raise one hand. 7 minutes, raise the other hand. Okay? And keep staring at the person who's making the presentation. Okay? So let us start, and I request all the panelists for the first session to please come.
First of all, thank you so much, ma'am, for helping us with all the do's and don'ts of this session and starting this session at such a lighter note. I request everybody to settle down as we are about to start with the first technical session, that is the bioengineered polymeric system. I request the moderator of this session, retired Professor Dr. Anup K. Ghosh, Department of Material Science and Engineering, IIT New Delhi, to take over the session. Among all the speakers, we have Dr. Ramanuj Narayan, CSIR, IICT Hyderabad. We have Dr. Amit Kumar from IIT Guwahati and Dr. Smith Mohanty, SIPET Bhubaneswar. Over to retired Professor Dr. Anup K. Ghosh for this session.
Good morning to everybody and welcome to the first session. I think it's very important and very required and significant session, I'll say that. Madam Secretary already have informed about it, and he has conceptualized this theme program, and we want to go ahead with this, and this gives an opportunity for all the COEs to present their innovations, the work that has come out, the work that has been patented, work that can be placed in front of the industry, our partners who are already here. And let's see that interaction goes very well. And as we said that, be very limited with your time, with your presentations, and we'll like to have more interaction from the industry to see what are the takeaway innovations or the takeaway points. And we would also like to have suggestion from the industry at the end of the session that which are the areas related to that will be more significant to bring about, okay? So with that, I would like to first introduce Dr. Ramanuj Narayan. Dr. Ramanuj Narayan is Senior Principal Scientist and Chair of Polymers and Functional Materials Department at CSIR, IICT Hyderabad. He is also the Dean of Chemical Sciences of SIR. Prior to joining CSIR IICT, he has worked for Tata Steel Limited, Tata Autocom Systems Limited, and Asin Cosmos R&D Company Limited. He specializes in polymer coatings, nanomaterials, and third-generation solar cells. He has so far 105 research papers, 6 patents, 8 process technology transfer, 5 book chapters to his credit so far. He has also edited 1 book and many conference papers. He has delivered around 70 invited lectures, which includes 3 keynote addresses. He has 6 research scholars who have been awarded and 5 pursuing the 5 PhD under his supervision. He has also supervised the dissertation work of more than 25 postgraduate students. He is the recipient of IPA Award and 4th Barger Elite Research Award for Coating Research and Newton Prize for the Solar Cell Research. He is the alumni of University of Delhi, NIT Jamshedpur, IIT ISM Dhanbad, and CSIR IICT for his postgraduate in technology and doctoral research. He has visited England, Italy, Scotland, France, Switzerland, Japan, and South Korea for different research assignments. He was the project coordinator of CSIR multi-institutional project Intel Coat and completed several industrial and strategic sector projects. With this, we see that he has both industry and academy involvement. I have been involved with a lot of COE meetings with the group, and this we have put 4 themes together. The first theme is on bioengineered polymer system. And this time we thought that these are the 3 institutions, 3 COEs, we put them together, who have already shown their theme research areas to be formulated in this particular area. So with this, we invite Dr. Ramanuj to give his presentation on coatings.
Presentation loaded है ना? मेल स्मिता की है ना कंपाइल प्रेजेंटेशन टोटल स्मिता किया था ना it is compiled na mistake हुआ
क्या हुआ सर ये है ना सस्टेनेबल ग्रीन मटेरियल्स पीपीटी लोड नहीं किया नेट नहीं ये मैंने पेन ड्राइव में लाया हुआ
चलो विजुअलाइजेशन चलो प्रोजेक्शन नहीं आ रहा है Should I start, sir?
Yeah. No. Time starts now.
Okay. So slide you can see later. So respected chairman, sir, Director General CPET, sir, all the higher officials, Secretary Madam, and all the higher official Krishnan, sir, and all my industry colleagues. So I will not take much time in elaborating that what this center is meant for. These things you are knowing very well. So I will directly go to COE on polymer coatings, decorative, protective, and strategic application. At the outset, I thank the DCPC for granting this center in the time of Corona, and the objective, because when it was visited, that whatever industrial problem, so whatever we have interactions with the industry and strategic sector in last 10 to 12 years, so those articulation, and as Secretary Madam told, that only we have to take those material which can be scalable, which can be functionalized. If we'll start from the very new, it will not see the light of the day. That's why we have taken in the alkyd, acrylic and hybrid emulsions, which are, all of you know who are working in the paint industry, that it is being used most widely by our large as well as MSME industry. And then how to promote that water-based system, and can we develop a polymer system which is thin enough that it should behave like a water, so in future water will also a problem. So all programs of this center is related either to a strategic sector, that where you have to increase the high performance, that is import substitute, and other thing that how we are going for sustainable development. And in paint industry such that any person can have a startup, because there are more than 600 raw material being used, and this center will help you. But with the blessings of DCPC as well as CSIR, we have a completely full-fledged center to run this. Some of the research highlights that why we are doing acrylic, innovations we are doing, that tomorrow whatever you are trying to see, that cross-linking polymer or these things, how to improve the acrylic emulsion on the plastic substrate, and how it will give a adhesion to the different substrate. Can you do the spot rusting prevention? Say water-based system can directly go onto the metal. That's why this innovation is that how you will combine acrylic with siloxane, and if you give higher solid content, it will take less water and you will get a thicker film. So in that direction, and this technology almost around 5 to 10 liter scale, what we can do in the lab, it is available, and further you can functionalize for super hydrophobicity and those type of system. So these are the aspects that molecular engineer, adhesion on different substrate, flexibility in formulation, spot rusting, low VOC coating formulation you can try. Then second one is that we are very good in the, because this themes comes under bioengineered polymer, that IICT is having a very good IELTS technology department. So we work in collaboration with them. We exploit the castor oil chemistry, whatever functionality, whatever chemistry you can think of, those things we have done for the coating as well as for the foam industry. And even today, just before this cashew nut cell liquid, we were the world's largest producer. We are the best different products, but everything is getting exported, and we value-added product will come as an import. So once again, we have realigned the wheel. So cashew nut cell liquid and castor oil, whatever chemistry, whatever technology, that's one for coating formulation. How can you make a polyol which doesn't require solvent for 100% solid coating, and then foam, that which type of, whether you can create a semi-rigid foam. So those specifications is written in that, and anytime it is a scalable technology available for all of your use. Then this was the very innovative concept, that this concept was when I was working for Tata Steel. Can we make a roofing that for Indira Awas Yojana and those type of system where your steel is rolled at 0.5 mm thickness, earlier it was 0.9. So can you put a coating inside where reflectivity of a steel, and you can put a coating inside that will look decorative, you don't require any false sealing and this type of system. And if you see in a real-time testing at 0.6 mm coating, it has given you a thermal temperature difference from the top to bottom surface is around 8.2 degrees C. This means 1 to 2 degree air cooling, because air cooling will go from this, and all the R value, everything is mentioned here. This technology is available at 100 kg or 100 liter, whatever scale you leak, and anything that this place you can use a slag, this place you can go for epoxy, they can use for waste to wealth. Today modern secretary madam was talking about waste to wealth and all. So this is the technology where we can put lot of waste for making thermal insulation type of system, for air conditioning system, so these type of things, innovations. Any innovation on thermal management we can do, we have that capability and scale of system. And then a strategic sector, can you develop a high temperature resin? Because all industry will look for 1000 kg scale or something, but they will require only 300 kg. So institute like us will come into the picture. So that's why we develop high temperature resin, where 400 degree you can go for 35 kg per centimeter square. Then can you transition, due to Corona has taught you how to transition adhesive, the hydrophilic to hydrophobic. Only you spray, you can go the antimicrobial system. So that technology we develop, or any solvent-free formulation. I will not take much time because one hand has been raised. So this is the shop where synthesis to formulation to evaluation. I request all my industry friends, all industry colleagues who are here, or any center for excellence colleagues, please do visit us. please come to us. We have all the things under one roof: synthesis, processing, paint formulation, and paint evaluation, including lifetime. And I take this opportunity of CPET DG sir, that please do join us a 2 days national conference which will be organized in the September for the coatings, and that place I can talk and you have to deliberately listen, because that time restriction will not be there. Thank you very much.
Thank you. Thank you, Dr. Ramanuj. We have 2 more COEs in this session, and we'll be going through them. I would like to see how many industries have shown interest on this, found interest on this. If you can raise your hand, and we could see that, because we'll have a question answer interaction session after all the presentation. But I like to see that your interest from these very particular areas of coatings, because whether it's insulation, barrier properties, adhesion, I personally get a lot of inquiries, lot of and developmental inquiries, that can you give us this coating, can we do this? So it's a very good. And I remember when this Centre of Excellence was actually being considered, it was actually considered as one of the important areas where this COE should be given. And I think that those innovations are coming up, and that should go for commercialization as much as possible. I can see many interest, and we'll allow many interactions after that. Next, we would like to move on with IIT Guwahati on sustainable polymers. This will give you the other areas also, along with coatings and what are the new developments are happening. And it's a very active COE. I have seen all through whenever there was meetings and discussions happen, and a very important areas of sustainable polymers. Professor Bimal Katia was actually coordinating that, and he could not come. I can see that. I would have liked to see him here. But in place of that, Professor Amit Kumar, he is here, Associate Professor from Department of Chemical Engineering from IIT Guwahati. He had his degree of PhD from University of Delaware, USA, and he had his BTech degree from IIT Kharagpur. He had long experience. He was the head of the Center for Sustainable Polymers in IIT Guwahati, which is one of these important areas I was mentioning. And he is in IIT Guwahati from 2010. His research interests are polymers, polymer nanocomposites, molecular modeling and simulation, gas absorption, transport and separation, and micro and mesoporous materials. These are the newer materials which are coming. He had number of PhDs that has been completed. 9 of them are actually carrying on their research in many different areas with Professor Amit Kumar in IIT Guwahati. He also have patents in these particular areas which will be of interest, and I can see them. They may be connected with this, the COE which has been given, and which are very important for that. And he also had award, National Award for Technology Innovation in Petrochemicals and Downstream Plastic Processing Industry in the category of Innovation in Polymer Waste Management and Recycling Technology and Green Polymeric Materials and Products from Ministry of Chemicals and Fertilizer, Government of India, which was awarded in 2016. And he has been convener and co-convener many symposium which is connected with the sustainable polymer. So IIT Guwahati COE actually representing this many areas of sustainable polymers. But I would like you to be very short. You know. It was very long. I know when I was reviewing it, too many slides. Please go ahead. I invite you, Professor Amit.
Is this the one? I think it was the same presentation which sir was presenting. Oh, band ho gaya. Which one? Same one it will continue.
आपका इधर से शुरू होगा
Okay, Thank you, Professor Ghosh, for the introduction, and very good morning to all the dignitaries, industry delegates, all the audience members, research colleagues. So I'm here to present to you some of the research activities that we have been doing in the Center of Excellence for Sustainable Polymers. As you can see, the coordinator for the center is Professor Vimal Katiyar. The information to contact him is also here. So this center was funded by DCPC many years back, and recently I'm pleased to inform you that only last year around this COE SUSPOL as the core, we have also established an academic center on sustainable polymers where many faculty members from seven different departments actually are actively working on different aspects related to polymer research. So next I'll just briefly talk about some of the things that we have been doing at the center for the past few years. So as you can see at the top here, in addition to this Sustainable Polymer Center at IIT Guwahati, there are some other centers that we also have working in areas related to sustainable materials. Now if we talk about Sustainable Polymer Center, the main focus of our center is to come up with alternatives to conventional polymers which are bio-based and biodegradable. So if you can see on the left here, the cycle that we have of a typical biopolymer, what we aim is to have, what we are trying to do is to develop, obtain monomers from bio-based sources, polymerize them to get bio-based polymers, but the polymers should also be biodegradable. So we are looking both at the beginning of life and the end of life aspect. So in the beginning of life part, we are trying to have the raw materials for these polymers sourced from a bio-based feedstock, and the end of life would be where these polymers can be readily degraded, so that the current, we all know that the currently plastics are kind of demonized because of the fact that they do not degrade and cause a lot of pollution. So we are trying to address that by trying to come up with compostable plastics. So in this regard, we have worked with many different systems. The main plastic that we are focusing is on polylactic acid. So we are trying to come up with polylactic acid formulations which can match conventional polymers in regards to the properties that they have. So for that, we are trying to modify polylactic acid by including different filler materials. So here we have tried gum arabic, chitosan-based inclusions as well, which again can be sourced from bio feedstock. And we have observed very good reduction in oxygen transmission rate. That's a very important property for polymers when we want to use it for barrier applications. So we see that almost 10 times or 7-8 times reduction in oxygen transmission rate has been attained for these systems, and we can also process these materials into films, as we can see here. And we have actually been able to create films or extrude films of these PLA-based nano composites in our lab. Another important area is where we are working on polylactic acid modification through another filler material called cellulose nanocrystals. These are very good property materials whose inclusion actually leads to significant enhancement of properties of polylactic acid, and we are here able to actually we have come up with a process where you can reactively extrude the polymer and the filler together to come up with these films, and this reactive extrusion actually has led to a case where the necking is a problem which happens in extrusion. So we are experiencing necking for just regular PLA CNC nanocomposites. So that has been addressed by this reactive extrusion, and we have tried many different compatibilizers, many different formulations we have obtained. And it turns out that these materials actually can, after recycling multiple times also, the properties are not significantly deteriorated, the molecular weights are retained. Another very important, interesting material that we have been working on is what's called heat-stable polylactic acid. So regular polylactic acid, actually, one of the downsides is that its heat deflection temperature is quite low. So if it comes in contact with even material that's 60-70 degrees, it can deform. So we have we have worked on actually and successfully come up with this material called stereocomplex polylactic acid, where the heat diffusion temperature is significantly raised to almost 150 degrees Celsius. So that's a significant enhancement in this very important property attained by modifying the polymer and including some filler materials as well. Apart from that, this stereocomplex polylactic acid plus this HAP is hydroxyapatite. So these biocomposites we have also used to develop different these medical implant kind of devices. So screws, staple pins, all these things have been prepared in the lab. Another aspect that we are working on is this active coating of especially food products. So these are edible coatings that we are working on, especially chitosan based, where either through spray coating or dip coating, we can actually cover the material with edible coatings, and we have seen that the shelf life of these perishable food products is significantly enhanced. So whether it's green chili or potato, onion, tomato, we have tried on many different food products, and we see a significant enhancement in the shelf life. So I think my time is almost up. So composting also we have tested, and we are able to actually see that these materials are compostable. We have facilities for that. And many of the products that we have developed or we can develop include, so for just the PLA resin, using that we can make granules and fibers, cast film, filaments, and we have also used these materials to make thermoform trays and cups, and as I showed, biomedical implant devices. And we are also using these materials can also be 3D printed into various shapes as per the requirement. So these are some of the products that we have developed, and we have also demonstrated many of these in different forums. So I think with that my time is up, so I'll stop here, and if there's any questions, of course, during a discussion session we can have that. Thank you.
Thank you. Thank you. Thank you, Professor Amit, for that. See, this is another area where actually this Center of Excellence is working on biopolymer and bio-based polymer. And we all know that polylactic acid is one of the polymer which is very much we are looking for, but its processability is very difficult, and the modification of the polymer can make it to a very high performance applications. This is one of the things I personally visited this COE. I'm aware of the whole facilities that is available, and you can see lots of modification, lots of property development that can be done with PLA in combination with many other fillers, polymers, additives, and all that. That's what he tried to bring in. We'll let the floor open for all discussion after one more presentation. That's the third presentation is from CPET Bhubaneswar. It is on sustainable green materials, one of the important area, and you can see that these all three are connected to the bioengineered materials. Dr. Smita Mohanty is the director, principal scientist, and head of the CPET SARP LARPM Bhubaneswar under Department of Chemicals and Petrochemicals, Government of India. Dr. Mohanty has more than 18 years of experience in teaching, research, and technical consultancy. She has mentored group of faculty, scientists, and PhD scholars in their ventures. She has been author of more than 200 international publications, editors, authors of 16 books or book chapters with leading international publishers, and several patents to her credit. She is also the recipient of several prestigious awards like National Award by Government of India in appreciation towards technology innovation in petrochemicals and downstream plastic processing industry, Outstanding Research Faculty Award by Scopus Career 365, etc. I personally have a lot of interaction with Dr. Mohanty. It will be endless. And number of projects I have been chairing for CPET and with many other organizations in collaboration. I have seen how that lab has been developed with so much of facility. I think it is another wonderful facility for industry to come forward, interact, and take help from there, and it is already going on. Okay? Thank you. With that,
Thank you,
Dr.
sir.
Mohanty.
Thank you very much. A very good morning to all of you. Now, this center was established during 2013, Center of Excellence on Sustainable Green Materials. The primary objective of this Center of Excellence was basically for various types of coatings, as Ramanuj sir has said, but slightly different we have. So these are some of the technologies developed, what we have developed under this Center of Excellence, bio-based UV-resistant coating formulation. Now, as we all of us know that India is the second largest exporter of castor oil. So this coating was basically developed using castor oil as a base polyol system, and then polyurethane coatings were developed. And it was basically targeted for automotive liner components. I have already highlighted in the right-hand side of my slide, as you can see, TRL levels I have highlighted to various systems what we have developed. The second one was on deuterionic-based foul release coatings. It is basically foul release, that means fouling is a major problem. So here the coating which we established is that it easily with the spray of water, the foul is being released. So it has got super hydrophobicity into it, as well as it needs to have the marine resistant in that. So it was basically based on PU-based, PDMS-based system, as well as we had also incorporated many kinds of modified nanofillers into the systems. Then we have the third one, bio-based adhesives and foams, and in which we have engineered for various self-life as well as adhesive strength of the wood products which we developed. So it was basically targeted for wood-based systems. Similarly, with the gravel-based systems also we have targeted, which is in TRL level 8. I'll show you some of the things. And some of the bio-based foams also we developed in this Center of Excellence. The fourth one was targeted basically for recycled formulations from electronic waste, where Professor Ghosh was also a mentor with us, and we have developed several applications. So these are some of the technologies which we developed. I'll just show you some of the snapshots which we have transferred. Now the technology is also open for the industries who can come up and take up, and accordingly we can also develop more specific targeted set of deliverables. This was a NTPC Netra venture. As you can see, this is an adhesive system which we developed. Now NTPC in the thermal power plants, especially they spend nearly 53 lakhs for one concept cone. So it is an adhesive based formulation which we developed it from them. And because these are all the bio-based systems which we developed in case of this, with the support of DCPC, this was also a system which we developed, and we transferred the technology to NTPC Netra. Now the technology is also open for other power plants for ion exchange resin systems where these kinds of adhesives can be transferred. Then as regards to the bio-based foams, what we did especially is that one of the blowing agent, HCFC 141B, has been banned from January 2020. So what we developed is that we developed the same castor oil based foams formulations for targeting for different kinds of applications. It was a thermoware application, it was a discontinuous panel application, it was also for a seating application for Royal Enfield motors, motorbike and other things. So what we did is that we assisted many of the MSMEs here in the later part of the COE. The COE was from 2013 to 2016-17, but this was transferred during 2019. Based on the outcome of the COE which we came across, we did this developmental activity. Then another UV resistant coating, this is especially the castor oil based coating which is utilized in pickup liner trucks. That is in entire South America, they have got a pickup liner trucks. What happened is that the type of formulations we developed, we were especially through our publications and patents, we were contacted by one of the Mexicans for transferring the technology on these bio-based formulations. So this was a UV resistant coating, and as per the customer's requirement, we again tailored the properties, we again tried to earmark the targeted deliverables, and we transferred this technology to them. These are some of the recycled formulations. Esteemed panel is also aware of it. We started off segregating the plastics. Around 33 to 40% of plastics are being generated from electronic waste. Now out of that, it was in the earlier days, it was majorly were incinerated because there was no value addition out of it. So what we did the segregation type of it. We also did the hand holding. We also tried to make out some of the value addition out of it. So initial work we started with the support of MIT, and subsequently this was extended to all kind of application, whether it is a cable based or it is any kind of electronic waste which comes up from the major structural applications, all these recycled formulations were developed. So these are some of the things and some of the facilities which is now in demand because compostable polymers have come up with the ban of all single-use plastic applications. So the entire biodegradation test facility has been set up with the assistance of DCPC, and we have purchased lot of facility we have also established here, and some of the tie-ups also we developed. Now, as regards to some of the upcoming work which we are doing under this Center of Excellence, it's one of the RDSO requirement we are doing for a railway application, and some of the plastic and chemical pollution we are trying to do it with one of the Indo-Norway venture, as well as new direction we have taken the medical waste plastics. Now we are targeting the medical waste plastics which is being generated, and subsequently we are doing the value addition, like whatever the medical waste which is recyclable, they will enter again into the value addition into the medical, in the hospitals itself. And castor oil based PU which I have already mentioned, and one of the interconnective adhesives also we are developing. So that is all about this Center of Excellence. I have some products also which we have transferred, and the industry members who are present here can have a look at the products whatever we have generated from this Center of Excellence, and accordingly, if in case anybody is interested to develop something out of it or any targeted deliverables you need, you can specify to us, and we are open in taking up the work. Thank you so much.
Thank you, Dr. Mohanty. I think we'll open the floor now for your interaction, inquiries, and your suggestions. But one thing to be noted that I was seeing from all three COEs, that the translational research is actually gaining importance, and they are trying to show that they are in TRL 4 and above, which is very good. And CPET has shown it is on an average 7, technology readiness level from an academic organization, R&D institution to have started coming to that level. And if the industry can come forward and we have interaction like this, I think it will be more going towards the commercialization. So now I now let the floor open. So if you can be very specific, which particular product you are interested, or process, or COEs, or facilities, that will help us to direct the questions to the institutions that they are involved. Yes, Nigam, Dr. Nigam. You can take this. Can you please? You can.
Yeah, Professor Ghosa. I think I was in CVCB, Central Pollution Control Board, and for the plastics waste management, all the things, I have taken care. I was also in the drafting committee rules. So my very specific question why I am raising here, I think you might be all aware that in the pouches, sachet and pouches, for the pan masala and other things, the plastic layer is banned, So they are unable to keep their product intact, and barrier properties are not getting. So only the paper and foil-based material is allowed. What the problem they are facing, that whenever they use any adhesive, so actually in the rule also plastic layer is banned, and VMCH is also banned, VMCH adhesive. What I would inquire from all the researchers, and especially CPET, do you have any such layer, kind of adhesive, which is non-plastic, and while doing the material testing through FTIR or whatever the method, so it doesn't form a layer, and their product is also intact and layer is also not reported. So that can continue. So that sustainable material or layer is available. Thank you.
Sir, are you asking about a coating layer?
Yeah.
Actually, now what is the tendency, what they are doing is that in all the gutka pouches, are you referring to that? There is a dispersion coating which they are already into it, which is not, it is declared that it is a non-plastic based coating and it preserves the barrier and other things.
Madam, I think you are aware that especially in the rules, I've especially written all the testing should be done from the CPET, A lot of samples are coming to all CPET laboratories, they know. And I have been reported that the plastic layer is coming. I mean, adhesive plastic layer is coming, like ethylene layer, ethylene adhesive-based adhesive, and other based adhesive, plastic-based adhesive. So, I mean, that they're creating, last week also, one sample was reported there in the CPET Ahmedabad. And I mean, I would not name here, that plastic-based, that kind of thing, ethylene-based.
Actually, sir,
yeah, go ahead.
Yeah.
That with that adhesive layer that will be cured, that whatever Dr. Smita was referring to, that once we are putting edible type of system or biodegradable type of system, that is the solution. And that place people are looking for that. Suppose you have talked about adhesive. So starch-based adhesives are there, but that place water sensitivity is more. So that type of system, that whatever Professor Amit also presented, that we can increase the barrier, that is it will be improved barrier of the edible coatings, and that will solve this purpose, because carbohydrate chemistry and that crystalline cellulose and those type of system will come into the picture. So that type of coating is being used. Even people were looking for some, just suppose she was talking about UV resistant coating. So if you are taking a castor oil system itself, that castor oil system degradation is there. So how to improve that with a polyurethane system with non-tin catalyzed, because the problem of that place, this is a tin catalyzed. So tin is again harmful, so how it can go for a non-tin type of system. So those type of things refer to, sir, or any query is there, we will give you in a detailed analysis report to you, that you write to us.
Yeah, I also want to say that, yeah. So we, so what you can see that specialized coating technology are becoming available, and with your queries, and that can be answered, that technology can be given by COEs, and your very specific case, the problem can be given, and they can solve that, and that is what is coming up from COEs. So let's move on, because we want to be a little focused and brief in your question, and we will be also in your. If you introduce yourself and then make the question. Yeah.
Sir, I'm Arvind Goenka. I'm Chairman, Plastics Export Promotion Council. So the problem what we see here is that our plastics exports are not much, from India. They are much lower as compared to other countries, and imports of value-added plastics are also very high. The reason is basically that the quality of the products made in India. But right now what we saw about the coatings, the performance coatings which can enhance the product quality and which can enhance the performance of the plastic product, that can greatly improve the quality of the product and increase our exports and reduce the imports of value-added plastics as well. So we would like to disseminate this information to our members, and then they can contact you for their products. Sir, one more thing that, I am from the PVC industry, my industry, and we are producing PVC floorings. And in our product, we can use a lot of recycled material. But in India, the recycled material is not available, especially PVC. What is available is also not neat and clean. It is like dirty, it's mutilated. So if there is some kind of a technology where the waste is collected and, we can have a clean scrap out of it, maybe a clean granulate out of it, then it can definitely increase its usage in the domestic industry.
Sure, thank you for your suggestion.
I have a product which Dr. Biswal will show you. Actually, we have now from waste PVC cables, entire your cable industry, what happens is that the copper is taken out. Copper has got more value, so it is being electroplated, and other applications they are using it. But the PVC is incinerated. Now, as a part of electronic waste management system, which Dr. Ghosh, Professor Ghosh was our mentor also, so we have come out with specific technology wherein all the waste cables can be amicably used for tiling applications. This is one of them. As you can see, both the things are waste. You can go for a rigid tile, you can go for a flexible tile as well. You can tailor-made according to your requirements. What I have done is that I have added some fly ash also in it, because as you know that eastern part, we have plenty of fly ash. So fly ash, red mud, we modified it. there was a requirement for rigid tiles. So this was a rigid tile. Similar way, we can also fabricate the flexible tiles. Please send us your requirements and we'll be happy to address it.
This looks great, ma'am, because of course scrap from wire and cable was available, but because of the metal content, we could not use it in our process. But seeing this, definitely it looks very nice. We'll contact you, ma'am. Thank you.
Yeah, may I just...
Thank you. We have to entertain other questions.
I am Rajiv Dwivedi from Loya Corp, Kanpur. My question is to Professor Amit Kumar. He is working for the sustainable polymer. So based on his presentation, what I understand that mostly you are working on PLA based system. So whether my question to you would be, because PLA we have also worked, PLA lot of, you have shown that mechanical property and all, but what about that, whether any efforts you are making to improve the sealability, that PLA heat sealing property? And secondly, I will stop my question with only second question is, one is that PLA always processability problem already we have discussed, but the sealability problem, because afterwards whenever we talk about the PLA will be used as a film in place of single-use plastic, to heat sealing property. And second question would be that whether, because this definitely the COE is not only confined to PLA, because your title is sustainable polymer. So whether, because in North America and other parts, they are working on PHA, PHB also. So whether you have got any plan to work on those areas or you are only confined to PLA? Please.
Okay, so I'll just address the second part first. So PLA has been the focus. Most of the work has been on PLA and modified PLA. But we have also worked on PHAs, especially PHB we have worked on in the past and we are working. In addition, PCL also, polycaprolactone also we are working on. So PLA is the main focus, but in addition to that, other sustainable biodegradable polymers also we are exploring. So that's it. Regarding the first part, the heat sealability, so the heat deflection part, the fact that it at low temperature regular PLA deforms, that we have been able to address. The heat sealability, maybe I'll discuss with you in person later a bit more, but as such specifically, that part we probably will have to look into.
They have mostly worked on thermal stability.
Yeah.
But heat sealability obviously is a very important property for packaging. Yeah.
Sir, good morning. I am R.K. Vij, President Textile Association of India, and working with Indorama Synthetic, one of the largest manufacturer of polyester, PET film and PET chips. I just saw a notification last that this recycled PET bottle will be used in the foods and the beverage item, which is as on till today it is banned. So one thing I just wanted to know whether it is connected to you or not, whether it will be allowed only a bottle from 0.9 millimeter, 0.9 liter and above, or we can use that recycled bottle, some percentage on the lower size of the bottles also.
I understand it's a very important queries. We are all discussing on that. FSSI came up with this and we are debating on that, whether it will be in an inside layer, how much percentage can be used. But this is a COE, they are coming up with the technology, and so I may not allow that discussion to happen here right now. That will digress this, okay? So if you are interested, and last question, because we have to go for the other theme sessions also. If anybody is interested in a particular product, particular technology on these bioengineered materials that have been presented here from the industry side, who wants to kind of a taker for the technology, will be happy to entertain that. We may discuss separately during lunchtime also. Any other question on the technology or product? Yeah, Abhinav.
Good morning, everyone. This is Abhinav from Aspire Labs. My specific question is regarding the coatings which are like metal look like. Metal is somewhere between, it cannot be like biodegradable or so. What is your take? Are there any coatings or some projects which are required? Projects are working on metal look like biodegradable coatings. Thank you.
Yeah, that metal look like will depends on, because there is a two questions you are asking. One is a strength point of view, or one is a look like. So look like will be depend on the which type of pigmentation you are doing. So it will be metal look like. But if you are thinking to increase the strength of the system, then this graphene type of system, that which will give a equivalent to that strength, and you can formulate it with biodegradable, non-biodegradable, whatever you want, and even you want complete biodegradable with a strength, that will be come through natural fibers. So these type of knowledge are available, as Professor Ghosh sir told. Please come with a homeopathic type of your problem. Write to all the centers, and in not only in coating, in at least in our center, because all three centers will give you a complete sustainable solution. In thermosetting polymers we will do, in thermoplastic Smita will do, in biodegradation system our this sister, we are also coming together on a similar platform, and if we cannot solve, then who can? That is the challenge we have taken for this COE. You bring a problem, but it should be problem should be well defined with a full specification, and we will deliver within time. But problem discussion will take time, but once we will come, we will solve your problem.
That's true. You know, in coatings there is one thing called vehicle, the other thing is called formulation. So through this you can solve the problem. What we wanted to show, the capability that has been developed. You know, the infrastructure or the facility that they can bring an awareness to the industry. And I think you may be thinking, and you get exposed to that, and you may be able to think newer product, which you were already thinking, and then you know where to go. And the purpose of these COEs, I think, are becoming more fruitful because through these interactions we can see that. Okay. Okay, one last but very short, very brief.
बहुत बहुत धन्यवाद सर, आप सबको मेरा नमस्कार। मैं मुकेश कक्कड़ ऑल इंडिया रबड़ एसोसिएशन से रिलेटेड हूँ, और मेरा रबड़ मोल्डिंग का रबर रोल्स का काम है नोएडा के अंदर, ग्रेटर नोएडा में। सर मेरी रिक्वेस्ट ये है कि मुझे कोई ऐसा बताइए कि रबड़ के ऊपर रबड़ को सेव करने के लिए हम क्या कोटिंग कर सकते हैं। मान लो हम रबर रोल बना रहे हैं, रबर रोल्स को पार्टी को देते हैं, रबड़ अपने आप में है, लेकिन कुछ कंपोजिशन ऐसी आती है कि जहाँ पे रबड़ चलता है वहाँ पे एसिड कांटेक्ट होता है, तो एसिड को कांटेक्ट में अगर हमारा रबड़ आता है तो रबड़ जल्दी ख़राब होता है। तो क्या हम उसके ऊपर कोई ऐसी कोटिंग कर सकते हैं रबड़ के ऊपर?
हाँ बिल्कुल कर सकते हैं सर। उसमें जैसे आप एसिड कांटेक्ट बोले और अल्कली कांटेक्ट होता है, तो आप एसिड रेजिस्टेंट कोटिंग व्हिच शुड हैव ए गुड एडहेशन ऑन रबर, क्योंकि जब उसमें एडहेशन थ्योरी ज़्यादा इंपॉर्टेंट होता है, उसमें किस तरह का एक्सपोजर है उस तरह का कोटिंग बन सकता है, और उसी के लिए हम लोग काम कर रहे हैं कि दीजिए स्पेशल कोटिंग, एक मोल्ड रिलीज आता है और एक आप पैकेजिंग में दे सकते हैं कि जब वो यूज कर रहा है तो उसके ऊपर हम उसको लगा सकते हैं।
देखिए सर, दिक्कत कहाँ आती है कि हम लोग रबर रोल बना रहे हैं फॉर स्टील इंडस्ट्री के लिए।
हाँ,
स्टील इंडस्ट्री में जो उनकी कॉयल बनती है, कॉयल ऑनलाइन चलती है, करीब 1.5 किलोमीटर लेंथ में चलती है वो
जी,
और उसके ऊपर जब वो एसिड चलता है HCl और क्रोमिक एसिड, तो बड़ा हार्ड एसिड है ये। वो एसिड जब अगर रबर के ऊपर कॉन्टैक्ट में आता है तो धीरे धीरे वो उसको ऑब्जर्व करके ख़राब करता है, पहली बात। दूसरा निवेदन ये है कि जो रोल है वो शाफ्ट के ऊपर है, MS की शाफ्ट है, अगर जरा सा भी एक ड्रॉप भी उसके ऊपर शाफ्ट के ऊपर चला जाएगा, हमारा रबर लीक कहीं हो गया या उसमें कैविटी आ गई, तो शाफ्ट के ऊपर जाने से वो शाफ्ट टूट भी सकती है। तो शाफ्ट को भी प्रोटेक्ट करना है और रबड़ को भी प्रोटेक्ट करना है
जी।
उसके लिए आप कृपया
इसमें हम बात करेंगे, क्योंकि अभी सब लोग हैं तो हम लोग आप लंच टाइम में बात कर सकते हैं।
ठीक है,
इसके ऊपर हम लोग बहुत सोच सकते हैं, क्योंकि रबर का ग्राफ्टिंग भी हो सकता है, रबर को ही हाइड्रोफोबिक बनाया जा सकता है, एसिड रेजिस्टेंट बनाया जा सकता है कि आप डिफरेंट ग्रेड का रबर वहाँ दें इंस्टेड ऑफ कोटिंग। हम बात करेंगे आपसे।
थैंक यू सर।
Thank you. I think that was the purpose, that we understand your need and we can modify the technology or science which is coming up through the research for the utilization for the industry. I can do that. I think all of them will be available during lunchtime also, and I can see many one-to-one discussion will be needed. There are some products have been circulated. You can see them more also during lunchtime. Okay, so we can do that because we have to move on to the second theme session. You will see further more and more other interesting COEs, what they have come up with their programs. Thank you for your attention for this first session. Thank you very much.
First of all, I would like to thank all our speakers for sharing all those insights and our respected moderator for this dynamic technical session. And before you all leave, we would like to present our gratitude by giving you all the green certificate, beginning with requesting Dr. P.S.G. Krishnan, Principal Director CIPIT, to move ahead and present their certificate to respected Professor Anup K. Ghosh, Department of Material Science and Engineering, IIT New Delhi, with all the pride. Up next, I request Dr. Alok Sahu, Director CIPIT, to present green certificate to Dr. Ramanuj Narayan, CSIR IICT Hyderabad. Now I request Mr. A.S.N. Murthy, Director CIPIT, to present the next green certificate to Dr. Amit Kumar, IIT Guwahati. Finally, I request Mrs. Subha Jayaraman to present the green certificate to Dr. Smith Mohanty, CIPIT, Bhubaneswar. Once again, thank you so much, ladies and gentlemen, and we are more than sure that through all this knowledge sharing, we will get to new opportunities and newer products which will open the gates of new exports outlook for India in the global level. Thank you so much, everybody. Now we step to the next session that is based on the theme Polymers-based Biomedical Devices. Our moderator for this session is Dr. Manohar V. Badigal, Emeritus Scientist, CSIR NCL Pune. Let us welcome him on the dais with your warm applauses. I also request all the speakers of this technical session to join us, beginning with Dr. Asha SK, NCL Pune. Thank you so much. I once again request Dr. Smith Mohanty, CIPIT, Bhubaneswar, to join us back on the dais. Thank you so much.
Thank you for the kind introduction. Very good morning to all of you once again. My name is Manohar Badigar from National Chemical Laboratory, working in the area of biomedical polymers. Can you imagine a medical field without polymers? Right from blood bags, you can say disposable syringes, then knee joints, and so on and so forth. So without biopolymers, or without the polymers, it is very difficult to imagine the advancement in the medical field. Well, of course, we have 4 talks in this session, and 2 talks will be given by Dr. S.K. Asha from NCL, and 2 talks will be given by Dr. Smith Mohanty from CPET Bonipshire. So let me introduce Dr. S.K. Asha. I don't want to read the thing, what is given here. Dr. Asha is a very, very dynamic and very advanced research doer in the area of polymers from National Chemical Laboratory. She obtained her PhD from Indian Institute of Science, Bangalore, under Dr. Ramakrishnan. And of course, she has done a postdoctoral research at Eindhoven University in Netherlands. And she's very actively involved in polymers for solar cells, polymers, dye-sensitized solar cells, and variety of other polymers for electronic applications. And of late, she is also doing a lot of work in the area of 3D printing of polymers, and especially for the biomedical field. Because, you know, very intricate parts, very specialty parts in the biomedical field can be done by 3D printing, which is a very, very latest technology now in the area of making very intricate parts of the polymers. And of course, till now in India, we don't have any polymer which can be 3D printed. I mean, many of them are still really imported based on, GELMA, and many of these researchers are trying to develop indigenous materials for the 3D printing. And Asha has been working in that area for making this 3D printing polymers. She is also the chair of the Polymer Science and Engineering Division at National Chemical Laboratory, and she very actively published in very important journals called Macromolecules, Journal of Polymer Science, and she has been also the editorial board of Macromolecules for the last 3 years. Yeah. So I request Dr. Asha to give her first talk on specialty polymers for customized ready-to manufacturing. Thank you.
Okay. Good morning, everybody. And thank you, Dr. Badiga, for the kind introduction. Let me first straight away thank DCPC for this funding the Centre of Excellence at NCL Pune. So first, here I stand not only just for the Centre of Excellence that is established at NCL, but also for the Polymer Science and Engineering Division at NCL. So our NCL has this tradition of connecting with industry, and we have several collaborative projects with industries for the several decades also. And we also encourage entrepreneurship based on the product that we develop. I'm proud to say that from our division, there are 3 young investigators who have their own in incubation centers and entrepreneurs. They are entrepreneurs. So not only in the area of 3D printing is something we have just started a couple of years ago, and DCPC has funded this project. But there are other areas also we welcome. We invite the industries to take a look at our website and also visit NCL, because the polymer division has the entire gamut from the monomer design to various types of polymerizations, whether it is melt condensation, living polymerization, anionic polymerization. We have all those expertise there, characterization, everything there. And I'm also happy to say that our colleagues have developed a way of continuous flow polymerization of this living anionic systems also. So now moving on to the Centre of Excellence for Customized Additive Manufacturing. As I said, this was set up just a few years ago, and just immediately after that, we were all hit by the corona also. So DCPC has funded us with there's a sanction for 2.8 crores, and they have given already the first installment of 1.4 crore, which was additionally CSIR has also given 2 crores to start this center. And with this, we have procured several 3D printers, this filament-based printers, the light-based 3D printers, as well as bio 3D printers. And the objectives of the Centre of Excellence were to undertake research of both fundamental and applied nature to meet the industrial requirements, and publish the outcome of the research projects in form of patents and papers, hold regular review meetings with industry. So we used to do this biannual industry meet, especially those industries in and around Pune who are working on 3D printing. We used to do that, and we have taken input. We have also invited ARAI to understand what is the role of 3D printing in automotive industry there. So this was something that we had initiated there. So in our center, we have 3 main thrust areas. One is develop UV curable resin formulations. So these are, as many of you may know, that 3D printing, it can be either based on filaments. The polymer, so already it is a polymer and we extrude the filament, and that is called the FDM 3D printing. And the other is this UV curable ones, which is light-based polymerization. You start with a liquid material and light is shown on it, and then it forms the solid as it polymerizes. So UV curable resin formulation is one of the thrust area. Another is the composite materials. That is for FDM-based 3D printing. In this printing process, the polymer gets deposited layer by layer. So the problem in FDM is that across this layer, in this direction, there is a limited adhesion. So the strength in this direction is less. So developing composite materials to overcome this challenge. Then we also work on biocompatible polymers, which are, we develop new materials, and so there is a PI who is working on these biocompatible polymers also. Here I am just giving a glimpse of something we have initiated in our, in the research group. The UV curable resin materials are developed in my research group. We develop these, we have the expertise to develop photopolymerizable monomers. So like the shown here, these are some the work of PhD students at the moment. So this is something we have developed, amino acids. So these are all biodegradable materials. So 3D printed using biodegradable materials. These are amino acid based materials which we have converted into photocurable ones. Additionally, we can also tailor-made. We have, so for the photocurable materials, the problem is that there are so many things that come into picture. When light shines on the resin, unwanted areas also get polymerized. So you want to avoid that. So how do you avoid that? You normally, you add dye into it. So here what we have done, we have tailored the amino acid so that there is already a chromophore in there. So that acts both as a light blocker as well as it is a biodegradable material. So in addition, it gives the 3D printed object fluorescence also. So this way, tailor making, we can have materials that glow in the dark, phosphorescent materials, like those things also we have the expertise developed. And on the right side shown here is a PLA-based material, photocurable material. So PLA, as all of you know, the previous speakers also have discussed, PLA is it's a biodegradable polymer, and in the form of extrusion filament-based FDM printing is done. But the filament-based material gathers moisture, and that is the problem in keeping the filaments of the PLA also. So whereas what we have developed is linear and star-shaped PLA, which are photopolymerizable. So one advantage here is also that the UV curable based 3D printing, the adhesion across the layers is also improved because polymerization is happening during the printing process. That is one thing, and additionally the resolution is also better compared to the FDM based printing. So we have the expertise to develop these type of materials. Then this is my colleague, another colleague working in the COE. He develops the composite materials. Here what he has developed is that the PLA-based composite materials. So as I mentioned, when you 3D print PLA, the strength in the Z direction is very less. So what they have done is they have extruded with Nano Cellulose. So and this composite has equal strength compared to a regular normal, compounding based product developed using PLA. So here he has added some fluorescent materials also. So these PLA materials also can be made fluorescent. One of the requirements of the COE also is that we should attract industry funding. So as I mentioned, this was the Centre of Excellence was set up a couple of years ago. After the corona, at least some of the industries are approaching us. Some of the projects that they come to us are characterization, fundamental understanding in nature. For instance, this nylon powder. The polyamide powder is used for SLA, laser-based 3D printing. So each time the printing happens, so much of the material goes waste also. So understanding that some of the fundamental understanding, that is one of this. My time is up. I'm just concluding with one slide. So based on the industry interactions, what we understood was that industry is interested in peak-based materials. These are engineering thermoplastic polymers. How can you make UV curable peak-make material? These are something that we are actually initiating in the group. So with that, I will stop this presentation. Maybe I'll continue the next one.
Yeah, I think you can continue the second talk as well. So later on, we can ask the questions. Yeah.
So, okay. So this is the Center of Excellence that was established at Polymer Division in 2011 to 2015. The requirement for, or the objective of this Center of Excellence was to conduct workshops and training sessions with the industry. So that has been achieved. So several workshops has been conducted with the industry, polymer sector and industry, and some of the examples are shown here for the workshops that was based on polymer melt rheology using, so several equipments were also procured using these facilities, and this has facilitated the industry to come and use those facilities, and also we have conducted these training so that to use these type of facilities. So right now, from this, the equipments that were developed, a lot of publications, patents, everything has happened. And the PIs who were associated with this particular COE are now involved in other activities like fuel cell and all those things. So right now, this COE is, it is not functional. It is what I want to convey here is that the objective of the COE was to impart training to the industry as well as other interested people, and that has been achieved. So some of the highlights are development of new polymer grades for industry. Some theory people also were involved in. They have done some DFT simulations. Some catalysts were developed. So these were, this was a knowledge sharing based COE. These are some glimpses of the workshop that were conducted, training sessions where industry participants have come and interacted. This is the funding, and this is the facilities, high temperature GPC, capillary rheometer. These were all procured, and these were open to the industries to access also. So those are still there, the facilities which are still being used.
Yeah. Okay. I think we can have the discussion at the end. So I would like to request Dr. Smith Mohanty to give her presentation. I think she has already been introduced. Yes. So just for the sake of this thing, she has an excellent research experience of 18 years, and she has more than 200 international publications. So I request Dr. Mohanty to give her presentation.
So this is basically, this COE is on bioengineered sustainable polymeric systems. Now, as you can see that there are three different aspects. It is again a combination of both, fundamental research as well as applied research. So first was eco-friendly biodegradable polymer films in agriculture sector. Second was in the membranes for healthcare and biomedical technology. And then we had energy harvesting and storage devices. So as far as this COE is concerned, we have come out with the agricultural mulches. Now practically what we have done, as you can see in my slides, this is all the trials. This COE got approved just before COVID. 2019 December it got approved. After that 2020 there were serious lockdowns and other things. So but still we were able to achieve the up to TRL level, the agricultural mulches. We have been trying out with the basic mulches which is available here. I mean the PE based systems, whatever is available, as well as the PLA PBAT range, PLA starch range, the compostable mulches which is available in the market. What additional which we have done is that we have tried to, the processability we have improved. Then we had tried to add some of the additives into it so that the moisture content, the water retention, weed spread, then the soil temperature content, then your soil disinfection before sowing, all these parameters we established it. We have UFlex in this because there were several additive systems which have come up to us, coated systems which have come up to us. So varieties of mulches, what is the implications over the soil performance has been studied. And at the same time, We have also recently come up with, from Tata Chemicals, there were requirements of these varieties of mulches constituting of compostable polymers along with HALS, hulls added and few other additives added, especially for, tomato as well as wheat. I mean, it was restricted to few of the crop quality and crop production. So that is how this, this type of work was targeted. Then this is a typical guar gum based film which we have done it. This was a requirement from BRNS. What we did is that guar gum, they produced it, but there was some processability problem with guar gum based films and all. So what we did, it was a combination of the natural renewable resource based polymer. The idea is that because PLA is, the cost of PLA is quite high. So what we wanted to do, whether it is a mulching application or packaging application, we try to reduce the quantity of PLA and substitute it with any other renewable polymer so that, the inherent biodegradability aspect is maintained. So this is another film which we tried it out. And then there was a hollow fiber membrane. Now, as regards to hollow fiber membrane, this I would like to just, we are still in technology readiness level 4. I would suggest that 3 and 4. What we did is that the entire dialysis membrane which is available, we did the complete reverse engineering, the dialysis membrane which is still imported, and we have tried to fabricate the hollow fiber membranes out of it. All the filaments we have tried to fabricate it. We are still under study because some of the low antithrombic properties and other things are still under study, under progress. Then active materials for supercapacitors and DSSC, dye-sensitized solar cells. Here a lot of natural materials have been again targeted to achieve the desired deliverables. One of the product which we targeted for technology demonstration with HMEL, we targeted it, and that product to some extent we have achieved up to 7%. Although you can see in literature people are achieving 14%, but we were able to achieve up to 7 to 8%. So this is the readiness level which we have developed for this kind of thing. And this is the technology, the entire facility which has been established. I'll just switch over to the other COE, sir. So some of the patents, we have one patent filing which is under progress, and currently we are doing a lot of work for ITC Bengaluru as well as for ICAR CIRCOT, which we have started. Now the idea is that include the nano-sized fertilizers into these renewable resource-based polymers. So what are the nano-sized fertilizers? We are including it. Now recently with the wheat production, we are trying out with the nano-sulfur. So the nano-sulfur is being produced by ICAR CIRCOT, and the films are being produced by CPET. And what we are doing, we are jointly collaborating it, and on already the field trials we have initiated in this. And one of the additive system which we have also, OXO thing, that also we are studying. As a part of this study, again, the post-harvesting conditions also we are taking into account, because in the normal PEPP polyolefin-based mulches, the problem is with the post-harvesting conditions. So once these kind of mulches, if in case we are introducing it, what happens after harvesting, whether it is assimilating inside the soil or it is leaving out some traces of microplastics, that aspects also we have taken it under this study. The second one is next generation biomedical devices. Whatever madam has already highlighted, same 3D printing filaments, but medical grade 3D printing filaments what we are developing. As such, the PLA, as she has mentioned, it is very difficult because of its low strength and all. What we are trying to incorporate is the nanoscale fillers into it. So what are those nanoscale fillers we are targeting is that we are trying to add some of the nanoscale fillers where we can easily print out. Already hydroxyapatite, lot of studies have been done with the caprine bones, and this has been modified. Similar kind of work also we are doing it. This is a startup which is associated with us. We have developed during the COVID period also, we had developed the masks and other things, but all the corset and other things we are also in the area of developing. I'll show you some of the interesting things which has come up. One of them is bone implants, which has come up under this COE. One exoskeleton suit, where we are trying to reduce the cost, as well as we are trying to establish the printability as well as its properties. Then another thing is dental aligner. The entire dental aligner, if you see the dental aligner, it from polyurethane methacrylate resin, it is being imported. So recently we have come up with a startup who has approached us. So for him, under this COE, we have been developing this polyurethane methacrylate resin. I have the complete product also with me. So that aligner component we are developing with that. Then the third part is the absorbent core material. Now, when we started the work, we had initially the pre-feasibility research was already undertaken. So we combined with one of the stand-ups, Vicuna Living Private Limited. With her, we developed the absorbent core for entire personal hygiene care products. It will target the sanitary napkins. It will target the entire sector of your adult diapers as well, which is in huge demand now. But the problem is that we are adding the polyacrylates. Here what we are doing is that from the tribal district of Odisha, we are sourcing out the cotton. That cotton we are modifying it. We are trying to modify it with natural processes and trying to see that the absorbency increases. So this is how we are developing it with the core, and this is the established property what you can see that we have targeted. With the commercial value as well as with the neat value, we are trying to, now with the neat value, we have so far achieved this, and commercially we are targeting, we are now going to add some of the SAP into it, some of the super absorbent polymers into it. Instead of polyacrylates, we are targeting some of the renewable resource based polymer which can be incorporated. These are some of the antibacterial properties which we have taken. And another thing my colleagues, they are developing, that is health monitoring via patch sensor. This we have achieved up to level 2, and some of the patterns we have established as regards to piezoelectric, piezoceramic inks, the stability we have established. Now we would invite the industries in case anybody comes up, then we are happy to target the deliverables accordingly, and a specific product can also go into that. Some of the patents we have filed it recently. One of them is under progress, other one we have filed it. And as a part of the revenue generation of this COE also, we were contacted by Manali Petrochemicals for development of a PVC tubing for, transparent PVC tubing for biomedical application. Shortly, last month we have transferred the technology under this COE. So that is all about this COE. Thank you. In case of any questions, I have also few products which I can display it. Anybody requires any specifications or any specific things, it will be my pleasure to answer you back. Thank you.
Thank you, Dr. Smith Mohanty. The floor is open for discussion now. The first two presentations given by Dr. Asha. In the first presentation, she has worked in the area of, as you all know, she has worked in the area of 3D printing, and secondly, she has worked in the area of composite materials, and so these are some of the interests she has. And she has also created this facility in the lab, this 3D printing facility she has created in the lab, and so anybody who is interested to collaborate with her or to develop a new materials for medical applications, they are most welcome to discuss things with her. Now you can ask any queries to Dr. Asha on the first topic. Yeah. Kindly introduce yourself just before the query. Nobody is interested in the 3D printing?
I guess when we were conducting this biannual meetings also, most of the 3D printing industries who came were for metal 3D printing. So the polymer, then that is why they suggested that go up with the engineering thermoplastics like PEEK. So then we started working on those, because the normal ones, not many, and the type of funding also, it is not possible for them to support. So or one thing that many of them want is a formulation, because when they buy a printer now, they have to buy, it's a proprietary, the material comes proprietary. So if possible, develop a formulation. So that is not also such a big scale industry as such. So maybe this engineering thermoplastics, if something can be developed, I believe, otherwise it is mostly, I see that it is metal based. That is industry.
Yeah, particularly based on the polyether ketone she has presented, I think there is a lot of scope in doing this 3D printing
Yes,
for the automotive applications.
Also for cranial implants, what they were saying was that right now for cranial implants, 3D printed titanium alloy is used for cranial implants, whereas PEEK-based material, it can replace those titanium-based material. It is lightweight also. But the PEEK, if you have to 3D print, the printer is also high temperature because its TG all is very high, so the extrusion has to happen at high temperature. And some industries who approached us also wanted us to train them on using the printer, because handling the printer itself is difficult. So then they wanted a modified PEEK, something like that, which is something that we have just initiated.
Thank you. Myself Sanjay Mendita from Toy Zone. We use 3D printer in toys when we make the models, new models. So we start from this only. First we make the samples from 3D printer, then we pick the molds in CAD/CAM, and then start the productions. So this is very important for us.
Prototyping.
Yeah.
Oh, yes, that is so. There, that is, it is the formulation. So I believe currently the formulation is exported, or there is no, in India at least, there is no established facility for developing those formulations.
We use ABS kind of the things for this prototype right now.
Yes, majorly the ABS based filaments, what you find it in the market, it is usually what madam says is imported now, it has come up. One canister costs around 830 rupees per kg. Yes. Now what we are doing is that as a part of this COE, we have been also developing the filaments. The entire filament setup facility is also being set up at CPET Bhubaneswar, you can see. And moreover, as a part of an extension study, like electronic waste constitutes of lot of ABS based waste. Now we are trying out to print, produce the filaments and subsequently print it for 3D printing applications. So that is one aspect. So you need not have to explore for, your filaments for buying them from abroad. Rather, we can teach and we can handhold the filament process, the filament fabricating process, and it can go subsequently for any kind of applications.
Thank you, madam. Thank you.
Yeah, also one thing I did not include here is, with, along with Reliance, we have recently developed glass-filled PP for filament extrusion base. That is something we have started doing.
Thank you, madam. Please teach us, because this is very important for us. We use it very big way.
Please write to us, we will address.
Thank you. Thank you.
Any other questions? Yeah. If there are no more questions, we go to the second theme. Second thing was again from Dr. Asha. Of course, it was basically the objective was to for the facility creation. They have created high temperature GPC, then many of the capillary rheometers, rotational rheometers, and they gave a lot of training to the industry people. Of course, in industry, people have the instruments, but they don't have a proper knowledge of complete utilization of these instruments. So in these workshops, the experts gave talks wherein the full utilization of the equipment could be done on rheometers or on high temperature GPC or any other equipments like that. And another thing is that they also trained the students of the institutes where all these research activities are going on. So the workshops are conducted. And apart from this, they also published papers, scientific papers, from the Centre of Excellence, and they also filed some patents.
I would like to add to that, although I said that COE is over, but we still continue doing the skill development program. So all these instruments, regularly we conduct industry as well as for students, we conduct these trainings that is going on. Sometimes some of them are 2 months, some are 3 month certification project, program skill development, that is still ongoing at NCL.
Yeah. So definitely the objective of the COE has been achieved. With all these activities. Okay. So coming to the third talk from Dr. Mohanty, she has worked in the area of agricultural mulches, guar-gum-based materials, and in fact, agricultural mulches TRL is 7. So it is almost like, it is ready to transfer the technology. And also she has made hollow fiber membranes, medical grade filaments, and dental, and of course super absorbent polymers. In fact, super absorbent polymers were developed way back in 1965-67 in the United States Department of Agriculture. Basically, the super absorbent polymers were accidentally developed. You know, they were doing something. Starch is not a moldable plastic. It's a biopolymer. You cannot mold articles from starch. So in America, there are a lot of starch, corn starch, potato starch. They were trying to make a moldable starch. And in that, accidentally, they discovered the superabsorbent polymers. They started absorbing large quantity of aqueous fluids, and also it has started absorbing body fluids like exudates from body, sweat, urine, and all. So initially, the focus was on agricultural applications because it was absorbing large quantity of water. It absorbs almost like 1 liter of water. 1 gram of this polymer takes 1 liter of water. And of course, from the body fluids, it takes little less. Saline or urine, it takes about 150 milliliter per gram. So knowing that, people started using this for ladies' sanitary napkins, diapers. Now the dream in India is to make a ladies' sanitary napkin 1 rupee per napkin, because that is affordable for all the people. So the idea is to develop the superabsorbent polymers indigenously. Unfortunately, although they were developed like 2 decades ago, and in India there is not much work in the area of superabsorbent polymers, particularly for healthcare applications. So that is another interesting area where I think it is on TRL 4 now on this superabsorbent polymers making for healthcare applications. So the queries are now requested to Dr. Mohanty.
Thanks for your nice presentation. Myself, Anindo Pal from Solution India Limited. We are the manufacturer of ABS, SAN, polystyrene, all the raw material in India. My particular question is for the oxo-biodegradable additive. It's a well-researched additive, this oxo-biodegradable, and we are listening about last 10-15 years about that. But so far, if we see in India, lots of packaging material, which is the actually cause of the waste management issue. This oxo-biodegradable additive is not used so far across all the commodity polymer packaging item. Why? If you please explain.
Because the problem is that it gets converted to microplastics. That's what they say. Otherwise, if you see their strategy, whatever is there, they use a catalyst system, pro-degradant additive, which they added to the packaging films or any mulching applications also that is being utilized today. So what they say is that once the molecular weight goes down, it becomes easily accessible by the microorganisms. But actually that doesn't happen. The microplastics are still persistent in that. The point of this, what we did is that we added all the systems. I mean, we have taken the compostable ones with us. We have also tried to logically modify the compostable, because the compostable polymers are not economically viable here because it costs are very high. So what we did is that the mulching films, what we tried out with different varieties of formulation. One of the formulation was also oxo-based systems, which we were also trying it out with the on-field applications. Because what happens after post-harvesting in the normal polyolefins, it literally becomes practically difficult to take out the tidbits of the polyolefins and then go for amicable recycling. So after these oxo thing, it degrades, I mean it disintegrates and defragments, because new technologies are also being coming up for oxo. So they claim that once it goes down, now it will be easily assimilated. So that is the study which is underway, because in the normal soil conditions we are carrying out. As regards to weed control, there is no problem with any of the films, whether you go for a normal polyolefin film, whether you go for a compostable film, starch-based compostables or oxo. Weed control is established. The release of the fertilizers, when you go for any kind of nanoscale range of fertilizers, how well it is balancing the soil, the post-harvesting conditions, what happens, those are the catch. I hope I am able to answer.
Yeah, since you raised the point that microplastics we came through that some bacteria are available. Some research has already done in India who can eat the microplastics and all. Any research is going on, any of the CPAT on that?
I think people are doing, many laboratories are currently doing that. There are, even in saline water also, these kind of oxoplastics, they are claiming that just recently in 31st March, you can see one article coming out from Symphony polymers, wherein these oxo-derived materials, it is being easily getting converted, assimilated by the aquatic stream. So these are still researches underway, and I don't think any concrete findings have come so far.
Okay. Now third question is regarding the guar gum. Guar gum you mixed with PLA,
yes,
right? Any study you have done with the polyolefins, because you know this polyethylene and polypropylene, these are the highly used this commodity polymer. And if we can add the guar gum with that to some extent, in certain percentage.
I think the films are there, ready there. You can, my colleague Dr. Biswal will show you some of the films which we have done. With the polyolefins also we have tried out, and with PLA, PBAT based systems also we have tried out. Please have a look at the films, because guar gum also is a very catchy and a typical material to process, although guar gum is available readily.
Because processing in the blow molding, in
yes,
this blowing
yes,
extrusion, it's very difficult with the polyolefins because of the temperature.
Yes, that is true. That's a fact. Thank you.
Yeah, I think yeah, please go ahead.
You are saying that, this is Dr. Chattopadhyay from DCPC. When you are saying that it is very difficult to extrude, I mean, are you extruding it with the normal PP or PE extruders, or you have to tailor-made? Because most of the extruders we have are for this, for extrusion of, even for the blown film also for either PP or for
Sir, normal.
LDP.
It is with the existing extruders, we are trying to, accordingly we are trying to modify the materials,
yes,
so that whatever existing machinery it is available, it caters to that requirement. There is no absolute no change in machinery part. The only change what we are trying to establish is the modification of the material part.
No, what I am saying, like if you do LLDP, you cannot process full LLDP in LDP extruders.
Yes.
So likewise, when the material changes, even if it is of the same polyethylene family, processing becomes difficult with the same equipment for other member of the family. Similarly, what I am saying is that if you are mixing guar gum with that, it is not 100% because it will not make 100% biodegradable.
No, it's not 100%.
With the normal PP and PE, if you mix guar gum, it will not make 100% biodegradable. Maybe the amount of guar gum you are adding, that much amount will be degradable.
Yes.
But to process it, again, you have to think of some separate novel equipment. That is what I was telling.
Yes.
You cannot just simply say it is difficult to process, but then you have to say whether you are using the conventional equipment. So that will itself pose a problem.
Yes, sir. So far we have been using the conventional equipment. The processability we have improved much better initially when we tried out, because the compatibility and other phases we modified it. Now we are able to process it. Processability doesn't pay much problem now, but the problem what you exactly rightly pointed out, when you are openly, when you are trying to biodegrade it, yes, only the component which is a bio-derived, that will only degrade. The rest out, it will be persistent. That is the thing. But if you are incorporating within a PLA, you are at one point of time, you are trying to reduce the cost, because 370 rupees, as we all know, 400 rupees comes per PLA, this mulching. Mulching variety of film also for compostable is still higher. It is 400 to 450 rupees per kg. That is a eco-bio grade which comes up. So what we are trying to establish, sir, here is that if we can reduce the cost at least by 200 rupees also, 250 rupees also, it's quite, I think, comes down in a better way. So that is the thing which we are trying to establish, sir.
May I ask one another thing, Dr. Mohanty? Maybe that neat PLA you may not be able to process also.
No,
you always, because PLA is quite difficult. Neat PLA cannot be processed without any processing additive, process stabilizers and all.
No, sir.
Hello. I'm Parth Mahapatra from Industrial, taking care of healthcare division. I have one question regarding biomedical device. You are talking about bone implants and dental aligner. What is the base material you are using for this research?
Polyurethane for dental aligner.
Yeah.
The aligner part
These are biocompatibility certificate?
Yes, yes. All those things have been established.
Okay.
Only thing is the resin formulation is being imported from abroad. Okay? The resin, which the gray one which you are thinking, that is the urethane methacrylate resin, which is being imported from abroad. The PET-G is the aligner part, the impression which it leaves behind.
This one?
Yes. It's a DLP based. 3D yes.
What is the process?
DLP based, sir.
DLP based.
Yes.
Yeah. Okay. Thank you.
That is underway again, sir, because so many resin formulation, we have done the reverse back engineering and then come out with some of the formulation. We are still doing it right now. This is a very new thing which has come up. Just last year we got sanctioned this project. So we are carrying out the work right now.
Healthcare industry compliance is very utmost priority.
Yes, sir. That is why a startup is involved in it. And parallelly we are doing our work and we are also assisting the startup.
For bone implants, any
bone implants, some of the things which we have PLA based systems which we have developed that.
Okay, thank you.
Thank you.
For the dental, have you collaborated with any dentists or anything? Yes, yeah. Because there is, I think there is an application where, this dental patches is a big problem. It's a disease. And people are trying to incorporate some kind of, like triclosan or something like that. So probably if you can develop, along with the triclosan, probably it will help in, preventing the patches.
Resin chemistry is more important because everything gets imported from Germany and they are selling it.
Any other questions? Yeah.
No questions, sir. Only we will supplement Smita in making that.
Yeah.
I am Ramanu, sir. We will help you in making urethane methacrylate. Okay. That whatever grade you are looking for in reverse engineering way, so we will discuss and another COE will come into your help as a backward integrator.
They have a strong background in making.
Because we are good at urethane, so we will help you in urethane methacrylate.
Yeah.
Okay?
Well, I think there are no more questions. I think we will wind up this session. Of course, both the speakers are available during the lunch time, and if you have any specific questions or specific discussion, you are most welcome to talk to them and then get your problem solved. Yeah. So I would like to thank both the speakers as well as the audience for the active participation. Thank you very much.
Well, once again, thank you so much to all the speakers and the moderator of this session, Dr. Biomedical. Before you all leave the dais, we would like to present you all with the green certificate. And as I request, Shri R.K. Soni ji, Director DCPC, to present the green certificate to Dr. Biomedical. Thank you so much. Moving forward, I request Dr. Asha S.K. to give the green certificate to Miss. I request Miss Shubha Jayaraman to present the green certificate to Dr. Asha S.K. Apologies for the inconvenience and details. Can we have a big round of applause, everybody? Yes, ma'am. And last but not the least, we promise you, Dr. Smith Mohanty, that we will plant more trees in your name. And since we believe in saving resources, we will give you just one certificate for the same. So for the increasing number of sessions that will be joining us, we'll give you only one certificate, but we will plant more trees. We promise that. Thank you so much, everybody. And we'll see you after the lunch break. Thanks a lot once again. polymer-based toys, I request the moderator for this session, Shri Sanjay Mohanty, Toy Associations of India, to join us on the dais. Can we have a warm round of applause, everybody? I also request our first speaker, Dr. K. Rajkumar, IRMRA Thane, to join us on the dais. Finally, I request our second speaker, Professor S.N. Joshi, IIT Guwahati, to join us on the dais as well. Thank you so much, everybody. Over to Shri Mohanty.
Hello. Yeah. Good afternoon, everyone. Myself, Sanjay Mohanty from Toy Association of India and Toy Zone Impacts Biomedical. Thank you to Mr. Krishnan. Thank you to all team of CPET to invite me, and welcome to all to this session. I just brief a little bit toy industry. Toy industry is very complicated industry, I think. Computer making is easy, but toy making is a little difficult, I think. There are many parts inside to be joined to make a toy. And toy is, some toys have more than 50 molds to make one toy. And inside have the many parts of toys inside, the gears, ICs, PCs, bearings. So every part of the, I say, is a commodity used in toys. I say all the components like toy, like bearings, IC, PC, PCB, polymer, and all kind of polymers like ABS, HIPS, all polymers was there, which is already used in toy. And we are Toy Zone in toys since last 37 years, doing in toy business. And toys really a big scope in India, like our Prime Minister says. Toys, really it's a go-to next, a very big level in India. Now in China is a world largest country to produce toys and hold 60% stake in all over the world. So I hope we, CPET, with the CPET, give us some more knowledge and more support to be achieve our goals and make India's #1 in toy countries. For the nation, for all the world. Thank you very much. And I invite Mr. Rajkumar and also Mr. Shri Krishnan Joshi to start the session.
Thank you, Sanjay Saab, for giving nice introduction. And first of all, I would like to thank the DCPC and CPET for organizing such a wonderful conclave, for sharing the knowledge and technologies which are developed under various COEs. And this COE is very, very infant in nature. It is just sanctioned, and in fact, the funds are supposed to get dispersed. But I'm very glad that to stand before, and we'll be getting more knowledge and experience being having these particular interactions. This COE is specifically at IRMRA as well as IIT Guwahati. So I will be covering the part of at IRMRA. Basically, it is I'm not sure. Just a minute. पीछे है क्या? Okay, okay. Sorry for the sequence. Yeah. So our COE is at IRMRA's design and development of value-added toys of rubber and allied finished products, basically. And just to give you, since IRMRA is about to start this COE, establish the COE, I just would like to highlight that, about what we are intent to do that basically. And it is basically to, focus on import of lots of toys, as high as 5,000 crore rupees worth of toys are imported, especially from China and other countries. So we have taken the survey of those, imported toys, and we thought of making substitution of such toys and also innovate more number of toys over here and enable our toys industry and sectors to market in India as well as give the opportunity to export basically. So this particular it's about total is 9.5 crores worth of this particular COE, and contribution from DCPC is 4.9 crore. And for IRMRA is another 4.9 crore. About IRMRA, it is Indian Rubber Manufacturers Research Association. It is as old as BARC, as well as IIT Bombay, as well as DRDO. It is well, well established organization since last 62 years. And we have several technologies to showcase, and this would be another COE where we will be adding more things basically. Just since we don't have technology on toys at the moment to showcase, but I would like to highlight some of those indigenized technologies which we developed for various organizations, just to have the knowledge of members and industry. We have developed, agricultural dam. Basically, it is flexible dams, inflatable, deflatable dams for water, management, resource management for agriculture ministry. It was a World Bank funded project. Then the indigenization of various shock mounts for the defense and nuclear applications, basically. So these are some of the products which are most significant, and they were all import substitutions for from Russia, Germany, France, and all basically. So we have enough experience of indigenization of the rubber and allied products basically. And acoustic tiles is another one which is for submarine applications. And also the nuclear, sectors, we have developed several products for nuclear resistance, the gloves and, rubber bootings basically. We also have developed a unique tire gel, which is puncture, proof basically. So if you inject this bio-based liquid inside your tubes and, things, even if it is punctured, doesn't, air will not come out. So this is being commercialized basically, and IRMRA is well, developed this technology and is being commercialized. Even this rubber dam also commercialized. So these are some of the technologies which we would like to highlight for the members' benefit actually. Coming back to the COE, basically, these are the facilities which would be established at IRMRA under the COE for the use of development of technologies as well as for the use of the industries as and when required. In fact, this would be strengthening our ties testing laboratory for certifications, which is being regulated by the Government of India. At the moment, all the ties which are subjected to the regulations of certain certifications from the testing laboratory. So we have also conceived some of the additional facilities required at IRMRA for doing this particular basically. And you would be wondering that, like, in the rubber sectors, even the erasers worth 10 to 15 crores worth of erasers are imported basically. It's not that the technology is not available in India. The only thing is that they have the economics which play a major role, and they are mingling with the ties and other things basically. So we have identified such key products, including the rubber bands, the rubber threads, and some plastic dolls, and these are some of the things which we have quantified. You see, look at these, the values which are quite high in price, which are imported, and they are very short-lived species in the market basically. So these are some of the ties which we identified, and we would be also coming up with lots of educational ties which we have tied up with some of the design institutes which would be manufacturing and developing the technology, and tied up with the industries to develop that basically. And present status, it is just approved, and letter is received from the DCPC, and we are processing other formalities to get the funding and applications for that basically. MOA is being signed and all the thing basically. So this is what we would like to share basically. We will be available, and if from the ties industries as well as our rubber industry representatives are here, we'd like to know from you what type of ties you want to develop from us, and what kind of improvement needed on existing, and what kind of certifications you are looking for. All those things would be helpful for us to incorporate such inputs to in our COE and for the future developments. Maybe when the next conclave comes, we would be coming with lots of technologies to show around. Thank you very much.
Thank you, Mr. Rajkumar. Thanks for give your knowledge to us, and we have some questions about it, what you can help into our industry, which we can later ask you. Thank you. I request to Mr. Shri Krishna Joshi to comment your comments.
Actually, I had submitted some other set of slides. So if somebody can help me to find out that. The revised slides. Huh?
Another one.
Other one, okay. Okay. Yeah. Latest slides.
I think you already sent to them.
Yeah.
So this must be on this actually.
It's this one.
इसमें है क्या?
No, it's not that. No. Polymers? No, it's not there. Okay.
इसको यूज करिए ना.
Yeah, ठीक है. Okay.
That's better. At least something is can cover up. एक ही presentation है. Continue thoughts.
Yes, no. Yeah, very good afternoon to all of you. My industry friends and the research colleagues, myself Shri Krishna Joshi from IIT Guwahati, and along with me Dr. Sajan Kapil from the IIT Guwahati for the same COE is also present. As Dr. Rajkumar has already said that we are in infant stage. We also have been approved one Centre of Excellence by Department of Chemicals and Petrochemicals at IIT Guwahati. The theme of this particular COE is on development of complete life cycle of the toys. And certainly it has to reduce the imports. Certainly we cannot completely eliminate the imports or cannot completely substitute. But certainly the primary objective of this COE is to reduce the imports. And the USP of this particular COE is that we are working on the three important aspects of toy design and development. That's the innovative design of toys, that the toys innovations as far as the designs are concerned. Second is the material innovation, and third one is the manufacturing of the toys as well. So these are the three main the objectives that this COE will be focusing upon during this coming 3 years of the development. We are 14 faculty members will be working on the COE simultaneously for 3 years, and there would be a team of research scholars and project staffs will be recruited during this course of action. And we feel very fortunate that at the start of the COE that we are getting the opportunity to interact with the industry. So the existing COEs or the developed COEs, they are after some time they are interacting, but it's very essential for us to get the inputs from you at the start itself so that we can focus our research and development to achieve that the targets or the objectives. In academia, we are working a little bit on you can say on the islands. We are working in our respective domain of research, and then collectively it has to be implemented for the industry. Under this group of the COE, the expertise would be available from 5 different departments. So Department of Design, IIT Guwahati, Mechanical Engineering, Chemical Engineering, Electronics and Electrical Engineering, and the Computer Science Engineering as well. And we are identified basically 5 different verticals that would be developed in this particular COE. The first vertical is innovative toy design, then sustainable manufacturing, sustainable material development, testing and safety. So we are having an expertise to have the safety material or the safe material development and testing of the toys as well. So these 5 verticals would be there. Certainly our design team is also very much focused on how can we have the effective marketing and branding strategies as well. So the status is there on the screen itself. Then this is our team, all the members from biomaterials, sustainable materials, design, sustainable manufacturing. These 3 on these 3 particular lines would be more focused. The first is the STEAM type of types. STEAM means science, technology, engineering, arts, and mathematics. So we will be focusing on development of the toys which are it's again age appropriate. So the STEAM toys will be required for the toddlers, for the school-going children, and as far as for the little adults and children as well. Then the next area that we will be focusing on the motor skill development for the young children as well. And the third interesting is that electronics-based, AI-based toys for the much more interaction and for the learning purpose. We have studied and we found that India is importing huge amount of dolls, the plastic dolls or the polymer dolls, which are these huge import. And doll can be considered, it's not in human form. It can be considered as the form of the vegetable or an animal or anything. So it's a hollow object. And what we have seen that the imports are huge. So these particular COE would first target on how can we have the effective manufacturing technology as well to provide some sort of relief for the imports. So these are our industry partners which are there right now on board. And I would like to, Sajan, can you add you something about the manufacturing here? Right, okay. The slides are not there, you can just, yeah, right.
So, my name is Sajan Kapil. I am assistant professor in the Department of Mechanical Engineering. I particularly work on the development of the 3D printers, and we build the machines and their softwares. So, as we are focusing on three main areas for toy manufacturing, the first is customized toys, the second is batch production, and the third is the mass production. So, when it comes to the customized toys, of course, the 3D printing cannot be replaced. We are focusing on developing the polymer toys, edible toys, even the hybrid toys by utilizing multiple 3D printers. But when it comes to the production or the mass production or the batch production, 3D printing is usually eliminated. But we are trying to introduce 3D printing for mass production and batch production, but not directly to print the parts, but to ally the processes like CNC machining, the rotocasting, and other processes such as the polishing. So, the first one, which is very important, is the injection mold. We found that a lot of injection molds are used for manufacturing the toys of plastic. We at IIT Guwahati have already developed a process called wire arc additive manufacturing, where a welding gun is used to deposit the material, and we have already repaired a few die and molds for few industries and give them back. So particularly for toys, if the die and molds are got broken somewhere, we can repair it automatically. There's a proper process planning for that, and we can reuse the die and molds. Similarly, if it comes to the batch production, the 3D printing can be utilized in an allied technology with the vacuum casting, where the pattern can be created by utilizing very accurate 3D printers such as SLA or the wax printer. Later on, we can develop the mold for rotocasting as well by utilizing the technology such as the electrochemical deposition. So with the help of 3D printing and allied technologies, we have found that we are really successfully able to develop some of the processes for mass and the batch production. So with this, I'll stop here. Thank you very much.
Excuse me, can I ask you? Just to show, you can do is mechanical toys or some gearboxes which use in the toys. You did already in India or not? Mechanical toys.
Yes.
You just put in the side.
Oh yes. Okay. The mechanical toys, particularly, for demonstration, the education purpose.
No. It's mass production.
Okay, mass production of the
toys.
No, mechanical toys mass production. Yeah, it's
inside the parts which is put in the toy. Yeah. You made it already in India or not?
Yes, we are trying.
Trying.
Yes, we are trying.
Still knows one factory in India who can give us the mass production gearboxes.
Yes, of course. That actually mass production of metal, when it comes to, we call it as rapid manufacturing. You cannot use directly 3D printing, but again with the allied, we can do that.
No. My question was different. My question was about gearbox of mechanical toy or.
Yeah, gearbox can be produced in the mass directly.
You produce already?
Yes, we can. It can be produced.
You have all molds already with you?
Yes.
No.
He's saying that whether the gearboxes of the gearboxes can be manufactured at the mass scale. Yes, certainly.
Yes, it can, and we can.
This is most requirement in India for these gearboxes.
We can even print it without
no big
assembly.
single factory have in India right now to complete the productions. This we still depend on China only. Thank you.
Fine, thank you. Here I end, and what we offers to the industry is industry can call us, we can reach to you, we can come to you, or you can come to at IIT Guwahati and look at our facility, which is already there. And with the COE, we are upgrading the facilities, and you can write to us. And what we exactly offer, we are offering the complete the life cycle or know-how about the toy design and manufacturing from the start of and we'll also help for the marketing and branding as well. So the design and taking the product at the market level as well. So thank you very much to the DCPC and to all you all for listening to us. So your inputs are very valuable to us. Thank you very much.
Thank you, Mr. Joshi. Thank you. We have one more person here who has very good knowledge in this industry, and he's with us, Mr. Sachdeva. Alan Sachdeva, I want to please come and give your views on this, please. Nikalo mask.
Good afternoon, friends.
Mask nikalo. Thank you.
Good afternoon, friends. I'm associated with Toy Zone for the last 3-4 years. In fact, prior to that, from my childhood days, I have been associated with this industry. My father had this business. So, little bit I know about the toy. I know about the challenges which this industry is facing. I rightly said this industry of 100 billion globally, and our size less than 2 billion, and out of that 2 billion, only $500 million is being produced in India. If we look at the industry size and if we look at our share, then definitely there is a lot of scope. If we think of just taking 10% of the share of the industry, that comes to 10 billion or say 75,000 crore rupees. Today we are at 1,500 crore rupees, 1,500 crore rupee to if you want to go to 70,000 crore rupee size, what is required? Required is big support from your associations, your colleges. Because challenge is that in India, the toy industry, one unit has to do everything. If you go to China, they have their assembly units, just assembly units. Every component, every part, every material is available. You don't need to invest on everything. Here you need to invest on everything. If I say total 3,500 crore rupees is the Indian manufacturing size, the number of units involved, 3,500. What's the average size? Not even 1 crore rupees, sir. There are units which are having 5 to 10 crore rupee or 50 crore rupee or Toy Zone with 100 crore rupee turnover. So if you look at the industry, they are very, very small units. They need hand holding. If you can groom these 3,500 industry or can create 10,000 units, then definitely whatever the goal our country is looking at, whatever our Prime Minister is looking at, we can achieve. It may take 10 years, it may take 10 years, 15 years. But if we get the support from the right quarters, it may happen in the next 5 years also. So that's what I would like to say. Thank you.
Thank you, sir. Thank you much. Thank you, all of you. Thank you for inviting us, and thanks for the session. Thank you very much. Any question, please ask. Let us know. Or suggestions, or your. Yeah.
Which materials you are looking for? Because if you are going for end-to-end manufacture, then which materials you are targeting? Because design is one aspect, and that's printing. If you go for 3D printing, or if you are going for simple mold type of system, which materials are being targeted?
Your question for this ITT or this is toy industry?
Yeah, the COE you are talking about.
Yeah, toy.
So the polymers basically, and even biopolymers as well.
Actually,
from 0% to 100%. So we'd be targeting all those things.
Any biopolymers or anything type of system you require, please take our help.
Yes,
we have a
sure.
group that you identify the material. Sanjay sir will also help you, and you categorize the material, pass it on to us, that what modification, what things are required, we will do for you.
Yeah, sure,
Okay.
sure. Thank you, sir.
Yeah.
Thank you, sir. Yeah.
Yes, sir, please. Please, mic to him.
Thank you very much for a nice presentation. The question is that after implementation of the BIS specification in the toy industry, we have seen that lots of import arrested, which was coming from the China. So there is a good prospect in Indian context for the growth in the toy manufacturing and all. So we have seen that MSME segment, they are working on very discrete manner, okay? And lots of work need to be done, the data collation and all, who are the manufacturer, who are the raw material supplier, and the right stuff need to be done, okay? So my request to the Toy Association of India, that if you please make a coordination with the raw material manufacturer as well as the MSME segment through all the, taking all the association, then only we can grow. So that is the submission.
Yeah, sure, we do already. We did already. We buy from that manufacturer only, like IOC and Reliance is our suppliers. In ABS, we say your company and SABIC is our suppliers. So we already did this.
Approach so far to us, because we have visited.
You have distributed system in India, so the distributor can talk with us. Like if I say Dinesh, DR Polymers is your distributor, he works for us.
Okay.
So like that.
Okay.
Yeah.
Maybe I can add that, in fact, you may be aware that like BIS constituted a new committee on the toy standards, PCD 30, which in fact I am chairing that committee.
Okay.
Just because our laboratory is accredited for toys testing basically. But I am still looking for the active members from the industry who can come forward and share the knowledge. And because there are only limited standards are existing so far, what is under certifications. And there are numerous components. If you see that even a single toy, there are number of components comes into picture basically, especially textile, plastics, rubber, electronics, so many things basically. So the challenges are that basically integrating all put together and then assemble and give a certificate of one single product. So the specification, designing a specification for a components, specification for the entire product and certification is really a big challenge for us as well as for the BIS and also government actually.
Right.
So unless the the industry come forward and integrate with all the inputs, it's very difficult for us to implement. Right. The intention is good and everybody is looking forward. The only thing is that I think first one seminar we already conducted from BIS, you may be aware that basically where we wanted to have identify the task which are the products which requires the specific the upgradation of the standards. So maybe that more such programs we would be taking regional seminars. Maybe BIS will have a regional seminar. We will also take the help of CPET and DCPC wherever possible. So we in fact IIT Guwahati also is being designer. We want to integrate all the inputs, and I request all those active members to become the member of that committee and give your valuable input so that our standard can be strengthened, and that will ultimately help you to regulate our internal products stronger and regulate the ban other Chinese product basically. And we will innovate new products which can in fact dominate our child to play with, rather than they come with any fancy items which doesn't exist more than a few months basically, 2 months, 3 months, that's it. In fact, I always say that one toy exists till either the battery exists or the next toy comes to the child. That's it. So it's a 5,000, 10,000 rupees they just buy and then they just throw away basically. The economy is wasted just like that basically. So it is our money, so why not we can control that. That would be our So if we are able to establish this mission, it would be a wonderful achievement for our things basically. I would like to thank the DCPC for supporting us in this mission. Thank you very much, sir, actually. Especially Sony Saab and who are very active in this particular, encouraging us to do that actually. Thank you.
Yeah, we will help you out in BIS part because already we are member in PCT 9, 12 and other 21, all those committee. And the second thing, we would request you to approach to Chemical Petrochemical Manufacturing Association as well. That is the CPMA. Because all the raw material manufacturer in India, we are a part of CPMA. So whatever the conference, whatever the upcoming seminars there will happen, it comes through CPMA, right? So that will be a good approach.
Good. I'll take your card and then we will interact with them. Thank you.
Thank you very much. Thank you. And also BIS is doing very good work in India and also in China also. Now import is open again, and the goods coming from China very soon. India again because BIS already give the license to China also. So import coming again, not restricted. Very soon. Yeah, finished good, yeah.
Yeah, because of the trade barrier, we have that liberty. Once anybody gets certified, they will be allowed. The only way to do is that we have to innovate new product which is not part of the Chinese product, and then you make your stronger things. By the time they duplicate and come to us, we should be much advanced. So we have to lead in that market basically. So there IIT and we wanted to be there. So we don't know, we don't want just duplicate only what is in the market basically. We want to do something new innovations which will bring in, especially educational ties. You present something which is useful for the child, not only for the playing but also for the education purpose, instead of just for playing. A remote car will never educate anything basically. Instead, if they can play with something in a useful way, and that will be wonderful actually. So we need to educate, in fact, we should bring into the educational system also basically. That's what we are working on that. Hopefully it will happen.
I agree with you, but it is difficult from China because China have a big force on the toys. Each house have one industry of toys. If I say in 1990s when I go first time there, only 400 factories there, on the very small factories, cottage factories there. After 5 years, with the support of government, they have the 5-star factories, 5-star hotel factories there. And now we will, the biggest in the world, 60% of the toy export they will hold from China only. So if we want to be do like similar, like they, government must be think for Indian toy industry in a different manners. There must be support, must be handhold, must be give knowledge, because this is labor industry. Many laborers, one factory can work 15,000 people in China. India also can possible. But this only need with the government support, not can only manufacturer or can do this. So I request to CPTT and also DCP can more help to the industry, so industry can grow up and give something contribution to the nation from the industry. Thank you very much. Thank you. Any other question, please? I think no. Thank you. So we finish this session here. Thank you very much. And please, everybody can come to lunch. Enjoy the lunch also. Thank you.
Thank you.
I thank all the speakers and our moderator, and we are sure that by discussion of these dynamic ideas, we'll be able to lay a better plan to position India in the global toy industry. And before you gentlemen leave, we would like to present you with the green certificate. I request Dr. P.S.G. Krishnan, Principal Director CPET, to present the certificate to Shri Sanjay Mahandirata. Thank you so much. Now I request Shri B. Ravi, Director ARS TPS Chennai, to present the certificate to Dr. K. Rajkumar. Finally, I request Shri Joseph Ben Singh, Senior Scientist, APDDRL Bengaluru, to present the green certificate to Professor S.N. Joshi, IIT Guwahati. Thank you so much, gentlemen, once again. Before we move towards lunch, I request Mr. Santoshi to join us on the dais for demonstrating the usage of the portal. Thank you so much once again, gentlemen. And now let us move towards the demonstration of the portal.
गुड आफ्टरनून फ्रेंड्स, जैसे कि आज आपने देखा हमारे माननीय मंत्री जी ने COE पोर्टल का उद्घाटन किया और उसके अंदर जो क्या चीज़ है, डिटेल्स है, उसके बारे में मैं आपको थोड़ा सा बताना चाहूँगा। जितने भी हमारे इंडस्ट्रीज के फ्रेंड्स हैं, आपने देखा होगा एक फर्स्ट टाइम हमने ये प्लेटफॉर्म तैयार किया है ताकि आप लोग जान सकें कि हमारे जितने भी सेंटर्स ऑफ एक्सीलेंस वो क्या क्या काम कर रहे हैं और उनको कैसे हम लोग अप्रोच कर सकते हैं। इसके बारे में हमने सारे डिटेल्स जो हैं अपने पोर्टल पे डाले हुए हैं। आप जब पोर्टल पे देखेंगे तो उसमें 13 लिस्ट जो सेंटर ऑफ एक्सीलेंस हैं, हमारे 13 सेंटर्स हैं, उसके सारे डिटेल्स हैं। प्रोजेक्ट कोऑर्डिनेटर कौन है वो भी आपको डिटेल्स मिल जाएंगे। कौन से सेंटर्स किस किस एरियाज में काम कर रहे हैं आपको सारा भी मिल जाएगा। क्या वो प्लांट मशीनरीज यूज कर रहे हैं, उनके पास टेक्नोलॉजी क्या है, वो सारी डिटेल्स आपको वहाँ पे मिल जाएगा, आप वहाँ से देख सकते हैं। अगर कोई भी इंडस्ट्री स्पेसिफिक इंफॉर्मेशन चाहती है तो हमारे प्रोजेक्ट कोऑर्डिनेटर को वहाँ पे आप कांटेक्ट कर सकते हैं और जो भी आपकी जो प्रॉब्लम्स हैं वो आप उनको जो है वहाँ पे सॉल्व कर सकते हैं। दूसरा चीज मैं आपको बताना चाहूंगा, क्योंकि अभी 2 महीने से ही हमारे 2-3 महीने से ही हमारे सेक्रेटरी मैडम ने जो एफर्ट्स किए हैं, ये फर्स्ट टाइम है कि इंडस्ट्रीज को कैसे हम जो है ऐसे प्लेटफॉर्म पे लेके आए ताकि हमारी रिसर्च जो है आइसोलेशन में ना रहे और उसका एक कॉमर्शियल यूटिलाइजेशन हो। जो प्रोडक्ट्स वो उन्होंने तैयार किए हैं कुछ में अभी रिसर्च कंप्लीट हो चुकी है और कुछ में रिसर्च अभी चल रही है। अगर आपकी कोई स्पेसिफिक रिक्वायरमेंट है, अगर वो भी आप हमको बता सकते हैं, या हमारे जो नोडल ऑफिसर्स हैं सीपेट में, डीजी सीपेट, आप उनको भी अप्रोच कर सकते हैं ताकि आपको स्पेसिफिक रिसर्च के अगर आपको कुछ कराना है तो उसके बारे में भी हम लोग सोच सकते हैं और कोई सेंटर जो है उसमें हेल्प कर सकते हैं। तो आप उनको जो है आप सारे हमारे पोर्टल्स के ऊपर डिटेल्स हैं, आप उसको चेक कर सकते हैं। थैंक यू वेरी मच।
Thank you so much, sir. And now we can move towards the lunch. We'll request everybody to join us back sharp at 2 so that we can commence the rest of the session timely. Thank you. to join us on the dais as well. Dr. Joseph Benson, I welcome sir on the dais. And finally, Dr. Vimal Srivastav, IIT Roorkee, to join us on the dais, along with Dr. G. Narahari Shastri, NEIST, Jorhat. Thank you so much, gentlemen. Over to Shri Rajiv Kumar Dwivedi.
Good afternoon. And definitely this would be difficult for me as well as our distinguished panel to keep you all in alert mode post-lunch session. It is always difficult whenever after having such a nice lunch and sitting over and listening all technical aspects. But definitely I am confident that myself and our distinguished experts will keep you alive or alert, attentive in this session. And to begin with, first, let me thank Department of Chemical and Petrochemical and CPET that they have organized this industry conclave. And to best of my knowledge, this is the first conclave and where these COE related activities are being shared with industry. And I am from industry. I am from Lohia Corp, which is, many of you may be aware that we are the largest processing machinery manufacturer. And globally, we have got a credit that we are, in terms of number of machinery manufacturers, we are one of the largest tape plant and loom machine manufacturing company based in Kanpur with presence in 90 countries. And this particular session, I am thankful to DG CPET and DCPC. They have invited because this polymer composite is interesting topic for any kind of machine manufacturing or machine builder like our company. Though I am moderating this session, but this will be, for me also, I would be keen to know that what our Center of Excellence, they are working in the field of polymer composite. Everybody has heard about Industry 4 revolution. Now we talk about Industry 4, or even in quite recently people talk about Industry 5 also. But if you talk about polymer composite, and to the best of my knowledge, that thermoplastic or thermoset based polymer composite, they are key to many automotive sector, aerospace industry, and machine building. Definitely in our company itself, we may be using quite a lot of polymer amide based composite. Even some of the composite, they always try to look at replacing many of metallic part which is used in machinery. So I would be also keen, and I will not take much time because this is my job is only to moderate, and I would start this post-lunch session. And I would request our speakers also to inform about the key output which is relevant to industry. As I think in the morning when this session was started, our Professor Ghose also told that what is the, sometimes we say intangible terms, what are the key takeaway of this COE which any industry can work upon. So it should not be like, and I think in the morning, Madam was also mentioning, Secretary Madam, that it should not be merely a research paper publication. Industry, when we talk about industry, look at that how whether this technology, whatever is developed within this COE or within the institution, whether it can be transferred to the industry or not. So with this background, I think all you have got the schedule, and we have this session is, we'll start with, I have got first, I would invite Joseph Bensing from CPET, and I know him personally also. He is, I think I forgot, he is a Dr. Joseph Bensing. He is already, he has done PhD. So Dr. Joseph Bensing is currently working as senior scientist, head of CPET, CPET COE. He is mechanical engineer with 25-year experience, and as such, I would just say that he has got a lot of credentials. I would not take much time, and I would request straight away Joseph Bensing to kindly present his activity of the COE.
Yeah, good afternoon. This Centre of Excellence on Green Transportation Network started during 2011, established at CIPET, ARSTPS, R&D Center of CIPET. This project in collaboration with the University of Toronto as well as industrial partner Canada, Ford, and a few more startups with Canada. So main objective of this COE is material research, product development, as well as skilled manpower development. Material research for eco-friendly natural fiber green material for fabrication of automotive parts, and skilled manpower in the area. So around 20 PhDs produced worked in the this particular project. So there are 4 themes in this. First, design and engineering of lightweight and sustainable hybrid green composite auto parts, development of dimensionally and theoretically thermally stable green composites, fundamental of rheology and interface functional components and surface engineering, performance evaluation, life cycle analysis, and prototyping. So mainly energy saving and goal to reduce the lightweight and increase the fuel economy. So technology developed through this COE, various prototype products were developed, automatic bumper components, mirror backplate, automatic AC panel, etc. Also expertise for lightweighting of sustainable biocomposite, nano enhanced structural hybrid composites, functional polymer blends, and nano composites. So various product developed through this as well as skilled manpower produced. So the various technologies for bio-based PP composite and bio-based hybrid with improved impact resistance, PP-based blend and composites, PP, EPDM based composites for various automotive applications, and its industrial readiness level also mentioned. So as told already, it is collaborate with the University of Toronto, Canada. So 5 our faculties of CIPET pursued PhD at University of Toronto and developed various materials and their industrial lab level as well as industrial level production scale materials produced and components also developed, and these components were validated through Ford Canada. So also this using this technology, we collaborate with MRPL and developed PP-based composites, and trials also taken, material data set as well as properties given below. So also in continuous with COE, as I told, skilled manpower produced through this COE, and we after COE 2011 to 14, and after 14 we developed a lot of product and supported to the industries. Technology also transferred. For example, for floating system for floating solar PVs, for in collaboration with the NDPC, we developed and installed up to 1 megawatt power plant at NDPC site. The technology also transferred with 10% royalty of each installation. So further, with the support of Government of India under solar energy research, we further studied with high performance, and because life is more important, life of the solar panel is 25 years. We try to achieve the life of 25 years of the material what we used for development of this floating system. Also micro-lattice structures for automatic component for lightweighting of various things. For example, car floor panel, we tie up with Mahendra and we are working on that. As well as for IG car, we developed many systems replacing metal things, only non-metallic components, full this cardio and endoscopy. So patient bed as well as cryostat and this gantry system for cryostat. So also we with this manpower as well as this technology lightweighting. So we supported defense ordnance factories, DRDO lab for indigenization of various products. Similarly, we worked with TOFE, this tractor system. So around 52 components of metal replaced with these kind of components. So that's our research, completely applied research, and the technology is already using by technology. These lightweight things are already available. Now we can for any applications, even medical field also. So these are the revenue generated after the COE establishment at the center. Various government projects as well as industry projects, industry, NDPC, defense, as well as DST, various schemes. So outcome told 20 PhD registered, 1 dropped out due to personal reasons, and publications and patent filed. So this technologies technology available at the center. We have a concept to complete product validation, concept, prototyping, production and product validation, all kind of activities in one roof. For design validation, for all kind of softwares, virtual simulation, all kind of softwares, and composite prototyping techniques. So also product validation, we have vibration analysis, multi-axial fatigue.
At the end of this session, some of you, if you are interested, will have an open session also and invite question and answer. And our next distinguished presenter would be, I think he is one of the eminent, I would say, scientist or expert in the field of material science. Professor Josman Jacob from IIT Delhi. I have his CV, which is quite, even he requested me that don't read fully. So I will try to, but still, this is my duty. Professor Jacob joined IIT only in 2006. He is head of the Department of Materials Science and Engineering. He is a leading material and polymer synthetic research group with emphasis on the design and development of novel material for diverse application. He has worked extensively in the area of semiconducting organic material for application in LED and photovoltaics. LED definitely is a area which we all talk about when you talk about energy saving. The group current focus include the development of biodegradable material from natural resources, material for controlled delivery or nutrients for agriculture applications, material for gas fixation and release, flame retardant materials, and hydrogel. So one of these objectives is there that industry also should know, okay, that this presentation is basically of HCOE, but this is a good opportunity that we all, as an industry, we can meet to meet different kind of eminent scientists, experts, because all these COEs are headed by those people. So this is also a good opportunity. And on behalf of DCPC and on behalf of this, again, I welcome you and I request you to give your talk.
Thanks, Mr. Dwivedi, for the kind introduction. Our COE is on advanced polymeric materials. Some of the products we have developed as part of the COE. The first work I would like to describe is from the group of Professor Ghosh, who is also here in the audience. So one of the products he has developed is based on biodegradable superabsorbent sheets. These are potential alternatives to synthetic non-degradable superabsorbent sheets. So he has put cellulosic bioinsert, which are superabsorbing, and this is completely biodegradable for use in biodegradable parts. Also, the group has very good expertise in the area of polymeric forms, especially using supercritical carbon dioxide technology. So, for example, forming of UHMWP is one of the focuses from the group. Similarly, forming of PLA. So these materials have potential for applications where sound absorption properties are important, or vibration resistant materials, or in EMI shielding, as well as for various biomedical applications. The summarized today is one is on the removal of heavy metal ions in the area of water purification. So here we have made polymeric analogs of EDTA, which is a very strong complexing agent. And this hydrogels based on these materials, they can pretty much remove all commonly found heavy metal ions from aqueous waste. And these materials you can regenerate and reuse without any loss in absorption property, actually. This we could demonstrate. We have 2 patents on this material. Another type of hydrogel which we have recently developed is in the area of polymeric Switter ions, where these materials can be used to fix any anions from solution. So you can have any anion which can be potentially sequestered by these polyswitch ions, and this has implications, for example, in the fertilizer industry. For example, we can use it for controlled delivery of nitrate and phosphate, or the same technology can be, same material, you can use it for desalination. For example, you can have a salt solution and you can completely remove most of the salt which has potential for application in desalination. Another work I want to describe is from the group of Professor Satpathy. Here, in collaboration with AIMS Delhi, he has developed suture-resistant, antimicrobial, biodegradable, and biocompatible fibrous patches. Also, he has developed hydroxyapatite responsive, cell-attachable, and stable surface-active biocompatible mats, actually, for wound dressing applications as well as for dental applications. So this work was developed in collaboration with AIMS Delhi. Another work I would like to report from the group of Professor Leena Nefani. Here she has developed functionalized silica. Silica is very important as a filler, especially in the tire industry. And what she has done is develop a method developed a method to produce functionalized silica starting from rice husk. As many of you know, rice husk has around 75 to 80% of silica, and she could functionalize it for better mixing with rubber during compounding. Also, she has made different types of gels which have antimicrobial propagation. Now, coming from the group of Samba Saha, she works in bicompartmental and multi-compartmental particles, and these particles can be tuned for different applications. For example, she has developed cytocompatible as well as infection-resistant polymeric scaffolds, which can be used for wound healing applications. And so this has a lot of biomedical relevance, actually. Similarly, she has developed oral formulation using Parkinson's disease, where each compartment has different drugs which can be released in a very controlled manner, actually. Now, coming from the group of Professor Tripathi, he works mainly in the area of polymeric membranes. So he has developed materials which are anti-fouling, which has relevance for water purification. He has also developed phase change materials which can be used for heat energy as well as for release. Also, he has developed redox active polymers which can be used in redox flow batteries, actually. Now, if any of you like to know more about any of the work, I'll be glad to get you in touch with the faculty who have done the work so that you can find out more. Also, as part of COE, these are some of the facilities we have developed: TEM, vector neutron analyzer, advanced compounding machine, AFM, WVTR, OTR, as well as fluorescence microscopes. So these facilities are also available for industry for use, actually. So with this, I thank, and I thank again DCPC for giving us a COE, actually, and for generous funding.
Thank you. Thank you, Professor Josman. Hope that his presentation would have been fruitful to many of industry members also. And manufacturing industry, when we get some imported component or something, we try to do a kind of reverse engineering, or sometime in a blunt language we say copying. So sometime I feel that most of this Center of Excellence or IIT or CPET, they've got access
of petroleum industries. Although we have about 5 crores sanctioned from the DCPC, we also have this whole project sanctioned for 25 crores with an idea that we will raise the money from industry. And I'm extremely happy to say that in the last 1 year we got about 8 crores from the industry. And we also have a large number of MOUs signed with 5 industries like PCPL, ONGC, NRL, oil. And in the first year, when there is one of the biggest blowouts in the Bogdan oil, we went there, and then our seismic team, the geoscience team, has played a very important role in giving the report. And afterwards, they also have looked at the soil, air and water pollution. And the report was given, and based on which the Supreme Court has delivered the order about the effect of it. So, although we have this polymer-based packaging materials where we would like to blend the natural fiber also along with the downstream products of the petroleum, the recycling of the waste to produce a non-woven fabric using different methods. This particular product is already at TRL4 to TRL5 level, and indigenously developed carbon nanomaterial based spiral wound and hollow fiber membranes. I just wanted to bring to your kind notice that the carbon nanostructures and their productions, we also have a mighty project in East, and for the first time in Assam, somebody got the Bhatnagar Award from our institute working on the carbon nanostructures. So we are building these facilities, and then we are using these facilities along with the membrane so that we will be able to develop some new smart materials for the recovery of oil, organics, heavy metals and biological impurities. And we have successfully implemented a project of separating the phenolics from the NRL project, the effluent treatment, where this particular removal of the phenolics appear to be very important to recycle the water. And another thing is alkyl acrylates, particularly methacrylates based on flow improvers, which is a very long project but a problem, and we are now having a relook at it to monitor the land subsidence in and around the oil field, crude pipelines of oil industries and assessment of state health oil installations, to work with a number of oil industries and then look into their products. I just wanted to bring to your notice that the 2 projects that we have started, they are now almost at TRL5 level. We also have found out how to bring them to the market. And another area which is of great importance that I personally feel that we have to integrate molecular modeling with artificial intelligence and machine learning, and in the process modeling, simulations and optimization in the oil industries. And although they have recruited some of the engineers to work on the AI and machine learning approaches, we are, personally, I am a computational scientist working in molecular modeling and artificial intelligence, and I personally took some interest to strengthen this particular area. And we also have signed MOU, signing with academic institutions and oil and petrochemical industries. And I am extremely happy that we have not only visited them, and all the oil majors have visited us 3 times in the last 1 year. And there is a very good ecosystem that is there. And I am sure that this particular capacity and capability building triggered by the Centre of Excellence will go a long way in strengthening the oil industry and bringing confidence of the oil industry in the academic area in the Northeast. So we have submitted 3 patents, and the patent applications have received one.
Shastri, though it was a short and brief presentation, but in the concluding slide you have indicated with his, I think he has already reached there, but still allow me to go through. He has handled several projects, consultancy projects over 15, total I think around 60 million worth of project he has done on behalf of IIT, and he has got a prestigious international award, Young Researcher Award 2010 by United Nations University and International Bureau of BMBF Germany. Professor Srivastav has also been awarded with national award like INSA Young Scientist Medal 2012, Hindustan Lever Award for Outstanding Chemical Engineering for the year 2020, and with his this, though it is so many other things are also written, but he's also maybe that our audience may not be interested, but this is from Roorkee to give a presentation. Professor Srivastav,
thank you,
yeah.
Rajiv ji, for your kind words, and thank you DCPC and DG CPET for giving this opportunity to present the work which has been done in the Centre of Excellence at IIT Roorkee. In addition, we are doing other works related to this, so I'll be little bit highlighting. I also like to inform that some of my colleagues are here also, and along with that, DG CPET was earlier leading this COE before joining us, so this is another thing. So in this project, actually, this COE is different as compared to others, that in this COE, the work that we have to do is more related to process development as well as wastewater management in different petrochemical industries. So the major 4 objectives of this project COE was that we had to develop process for 2 routes with respect to propylene or propane utilization. So one of the routes was synthesis of propylene carbonate from propylene or propylene oxide, and further and using CO2. So CO2 utilization was there. Then further converting the propylene carbonate into polyurethane. So that was the objective. So in a way we are going for utilizing CO2 and converting it into propylene carbonate, which can be used in many places, and then converting that also into polyurethane. Then the second route was oxidation of propane for getting acrylonitrile. So these were the 2 major routes that we had to work on. In addition, we had to work on the water management and treatment in petrochemical industries. So like water networking for reducing the overall water requirement of any industry, and also the treatment of wastewater which is generated in various petrochemical industries and chemical industries which are highly complex in nature and which cannot be treated by biological means in the traditional manner. So this was the major objective. So in the propylene carbonate, we have been working on propylene oxide, and this COE was established in 2019, so still the work is in progress. We have already done the work on the batch process. We are tentatively getting a CO2 conversion of 3%, which is you think that it is very low. It is one of the highest that we can achieve, and CO2 is not very easy molecule to work, and we are getting propylene carbonate in good yield, and this is the per pass conversion only. In addition, we are working for polyurethane synthesis from propylene carbonate via 1-pot process. In this case, we are using 2 steps for synthesis, and there also so we have been working in parallel. Like few of the colleagues are working on the one route, other colleagues are working on second route. So this also we have doing well, and we are getting good results. Then oxidation of propane to acrylonitrile, this particular route we have done very and we have virtually patented the things already. The work has been, the catalyst has been developed, and it has been developed by my colleague who is sitting here, Professor Prakash, and we have done already, the comments have been received and it will be filed very soon. So in all these routes, what we are trying to not only develop catalysts and routes, we are trying to work on the techno-economic feasibility of the overall process development, as well as try to see that life cycle assessment of the project and other aspects are also taken care of. So these are the major objectives through which we are working on these routes. In addition, this is the experimental analysis and other things that we have done. So we do work on all the aspects with respect to separation, characterization, as well as utilization of waste or any other wastewater or the air pollutants if they are coming out. So we are trying to wholesome work on the process development of these chemicals in particular via these routes. Now, in addition, the wastewater treatment in the petrochemical plant and other places is very complex. So we have been working on treatment of such wastewaters, and just to inform that we are trying to work on treatment of wastewater which is generated from explosive industries to other industries. And some of the cases, the wastewater has a pH of 0.5. You will not believe that industry generating a wastewater which is having a pH of 0.5. So we are trying to work on those wastewaters also, developing electrochemical or physicochemical routes for treatment of such wastewaters. And then also wastewater management in a petrochemical plant. This is this particular network is for a typical petrochemical industry in Bangalore. And we, as per the data till that we have received, around 9.5% water consumption reduction we can achieve as per the targeted approach that we are doing. So the work in the COE is still in progress, and we have already filed a patent already. For one of the first one we have already received the comments. Second one also we are in the process of filing. And in addition, the Department of Chemical Engineering at IIT Roorkee is doing lot of work with respect to wastewater treatment, industrial pollution abatement, as well as the process development. So, and recently we have been receiving a lot of interest with respect to utilization of CO2 capture, as well as development of other routes that we are trying to work. And this is a great initiative by CPET and DCPC that this particular meet has been organized, through which we can meet the industrial partners. They can suggest their work, and we can also, based upon what we are doing, we can highlight. So thank you very much. With this will end. Thank you.
Thank you. Thank you, Professor Srivastava. And before we open the question answer session, one question I want to ask to Professor Srivastava. One of the things you have shown that non-isocyanate one pot basis polyurethane synthesis without isocyanate. Yes. So that is you are able to demonstrate also in your laboratory, because like in our manufacturing we do a lot of polyurethane products are processed, for which we get polyol separately and isocyanate, and then we do a reactive casting in our. So I just want to know that
I like to just inform that only 5 days back only. So we are getting good conversion in that. Okay, and we have confirmed this through NMR analysis and other things. The work is still in development. So because this is a more research oriented work. Yes, so but we are trying to develop, because this type of work is not reported.
Yes, that is why the moment when you were showing, I got impressed with this non-isocyanate polyurethane, something is developed. So this is
this is what we are working on.
Yeah. Thank you, and I thank all of the distinguished speakers. And I am now. I think some of the audience, some industry member or somebody wants to ask any questions. So we have. I think you have seen all the presentation. Started with Green Transportation Network by Joseph Bensing from CPET. He has talked more about bio-based PP composites, some of the product sample also they brought, followed by Professor Josman Joseph from IIT Delhi. He has talked about some of the things what IIT Delhi CO is doing in the area of polymer gel and then membrane. Then we have seen from IIT CSIR Jorhat Center also. They have also given some of the information related to polymer membrane also. They are also working, and one particular thing which caught my eyes was that was related to face mask, what he was showing, that for which they have got, they have applied patent. So any member, any industry person or anyone, either the CPET students or anyone who is present, they want to know anything from this COE work, whatever they are doing, their queries, technical queries, or please.
Actually, my reference is to Bimal sir. So since you have gone from non-isocyanate urethane from the propylene carbonate too. We have also developed that using castor oil. Morning I was talking about the castor oil. That place we have to generate carbonate and then ring open with the amine. And almost we have made film also out of that. But it is not of the industrial scalable, but at least in polymer, whatever we are making, that is almost around 250 gram or something like that. But we are planning to scale it up. So we are through renewable resources, we are trying to, and we have developed that non-isocyanate urethane coatings. And that is coming to that one.
Yeah,
and
thank you.
Rajiv sir was asking on the composites, because I told you, because I am a coating man, so we have to put beauty to everything and add color to everything. Whatever machines you are doing, since these were the products, whatever we have shown you.
Yeah.
But whatever product you want, whether it is of abrasion resistant coating or anything, or if you want a smart coating which should self-fill, so all those things our COE can help you in all your manufacturing machine, corrosion protection, abrasion resistance, mining equipment, so those type of things on glass coatings and everything. So that we will send our all the technology, whatever we have, to our COE website, that you will able to know.
Yes, yes, definitely, definitely. Thank you. I feel that this is a good platform for interaction within COE also, and each COE they come to know that what other COE is doing. So even there are possibility of exchange between different COEs also.
I am Sachidandan from Hindustan Organic Chemicals HOCL. My question is to Dr. Shastri. See, we are manufacturing phenol acetone and hydrogen peroxide, and our problem is separation of the phenol from effluent. See, we are interested in this membrane technology. Now our technology is biochemical process, and it has got many disadvantages. Still, we are managing no problem. The limit is 1 ppm, the phenol. So we are very much interested in this membrane process. One, and this is connected with the phenol. Similarly, for separation of this methane from hydrogen, we are manufacturing hydrogen peroxide. For that, we require hydrogen. In that, we have got a methane excess is coming, which we are getting from BPCL. It has got more methane. It is not suitable. It is not preferred. So, if we can separate this methane by membrane, that also we require. Similarly, benzene, and our product is acetone. It contains benzene. Benzene limit is normally 2 ppm, especially for pharmaceutical chemicals. So, if we can reduce limit, suppose at some time only it goes above 5 ppm, 10 ppm like that. If that time, it is very easy to separate by membrane process. Other process is not easy. Distillation is not possible. So, separation of benzene from acetone by membrane, these three things is we are very much interested in this one. Possible, we want to implement also. I am CLRP, CGM CLRP there. So in future also we can implement.
Sure.
Sir, please help us.
It's really a big problem that when we have these organic effluents, the recyclability is a problem. So one obvious approach that people use is gravitation, which does not work. And the second is the biodegradation. That also has a problem. So the best way to go ahead is with membranes, but that is very expensive. So we will have to somehow utilize what is optimal. So now our group has taken a specific project from NRL because they have a huge problem with this water recycling. So we are implementing it. We are almost on the verge of a breakthrough through the membrane separation. So we will also look into that, where you have the phenolics is one issue, benzene is another issue. Phenolics is slightly different from benzene. And also if you want to separate benzene with acetone, we have the capacity to custom design the membranes for a specific task. That we will try to do this. The second question that you asked is about
methane, hydrogen.
So that's a very important thing, because the gas hydrates, clathrates, were being talked about, and they were remained as a textbook material and for publications. But one has to relook at these class rates.
Sir, actually we would like to discuss with you because
Sure.
phenol, this AMS, we have got alpha methyl styrene stream. In that also phenol is there 7%. We are reducing to say 1.5. Then only we are again feeding to some other treatment like that. If possible, that is a small stream, only 1 meter cube per hour like that. If we are able to separate by membrane, then also we can increase our productivity. That way we can discuss. I would like to discuss with you. And our unit
we
is
have a close to 2 crore project from NRL for 1 year, and they review it every 15 days to 1 month. So our people will be very happy to utilize that particular technology to other separation of the organics. And I am also very, very interested in the gas separation.
Okay, sir. Thank you, sir. Sir, our unit is at Kochi, Kerala.
Okay.
Okay.
Sure. Thank you.
And I'll ask question to Joseph Mensing that these are the products which you have displayed, where they are whether they are being used commercially or they have been commercialized, or it is in proof of concept stage.
Validation.
I think if there are no more questions, so
may I just talk about an issue? When I visit this BCPL Dibrugarh, the site is several dozens of trucks carrying high quality polymers go out of Dibrugarh. Anybody who visits this Tinsukia, Dibrugarh, they see that a huge number of trucks which go out, and there is not a single industry, plastic and polymer industry. If there is some way that one can come up with constructive approaches, we can even meet the Honorable Minister of, Chief Minister of Assam, and we can have a very good meeting, because the NRL, GM and BCPL, they are all working together. And if the DCPC or CPET would like to take an initiative, I will be extremely happy to facilitate that, because it's very important to see that the plastics and polymer industry and the downstreaming of the petroleum products, we should try to do it in the Northeast, because Northeast is one place where many of these things are happening, and we need to develop this capacity and capability in science and technology to leverage the benefits of the natural resources that are there for our own country. And also transportation also is very easy. We should try to target the Southeast Asia, and the Northeast is surrounded by 7 different countries, and then this should be seen as an opportunity for the industry people to come together and then work, just as my 2 cents.
Yeah, thank you, Professor Shastri, for sharing. I think ministry officials are already available, they may be hearing about this. And as such, I know that a lot of industry, they have come up also in Northeast, and CPET also has got a center in Guwahati. So CPET Guwahati has also been active in different kind of training activity, and if you talk about industry, I know that there are a lot of industry based in injection molding and woven sack industry, plastic processing industry. So even woven sack is a very big area in which our company, they supply machinery. So to my information, but only thing is that Northeast as such is a very, you can say area, demography is quite huge, because if you talk about Assam and Guwahati only nearby, we are not talking about other area like Manipur or Meghalaya or other area. Dibrugarh is again far from Guwahati, and once upon a time in my starting of career, I got my first recruitment I got in Assam Oil Division in Dibrugarh, but I didn't join this, sorry, Digboi. So, but that I know about that. But sorry, that is just to, in a lighter mode I shared. But definitely the downstream industry potential is available in Northeast. Northeast is as such a potential area. With this, I think it was a my thanks to all distinguished panel members and distinguished experts who have come over all the way from only from Delhi. Only one Professor Joseph was there. Otherwise, Joseph Bensik, they have traveled from Chennai, and Professor Shastri came from Jorhat, and Professor Srivastav came from Roorkee. So we must thank them that they have come over here in a very short notice and presented here. And whatever activities are there, this is the first COE industry conclave to my memory also. Definitely this is just we can consider it as a kick-off session, kick-off workshop kind of thing, that future definitely I'm hopeful that DCPC and CPET, they will join together and keep organizing this kind of workshop, which will be benefit industry and all stakeholders. Thank you very much. With this, we conclude this session. Thank you.
Thank you so much. Special congratulations to all the speakers and the moderator for pulling off this very enthralling session. And thanks a lot for joining us. Before you all gentlemen leave, we would present you with the green certificate. I would like to invite Dr. Alok Sahu, Director CPET, to present the green certificate to Sri Rajiv Kumar Dwivedi. And now I invite Mr. Avinash Kumar from CPET to present the green certificate to Dr. Joseph Bensing. Next, we would like to present the green certificate to Dr. Josmin Jacob. For the same, I request Dr. Manoranjan Biswal from LRPM Bhubaneswar to join us on the dais. Joseph Jacob. Thank you so much. Now I request Dr. Vimal Srivastav to present the green certificate to Mr. Manish Kumar from CPET. I request Mr. Manish Kumar from CPET to present the green certificate to Dr. Vimal Srivastav.
It's post-lunch effect.
And finally, I request Dr. Lakshmi Unikrishnan from APDDRL Bengaluru to present the green certificate to Dr. G. Narahari Shastri. Thank you so much, gentlemen. So finally, we come to the end of all the technical sessions, and moving on, we would now like to start with a presentation by Technology Development Board.
ठीक है प्लीज हाँ नहीं प्लीज प्लीज yes no please
Thank you.
Once again, thank you so much, gentlemen. And next, we would like to start with a presentation by Technology Development Board, which is a statutory body in the Department of Science and Technology and in the space of commercialization of indigenous technology. For the same, I request Commander Navneet Kaushik the program director to join us on the dais.
Respected Secretary, Chemicals and Petrochemicals, Ms. Aarti Ahuja, Directors, DG CPET, Dr. Shishir Sinha, ladies and gentlemen, good afternoon. Before I begin, I'd like to thank for having been given an opportunity to talk about TDB in this August gathering, because I feel today we are at a very interesting space where there is an academia which is developing a technology. There's industry which is supposed to use that technology, and here we are, who are supposed to commercialize the indigenized technologies. So the technologies are being developed, like whatever the slides which I saw. So TRL level 4 is already being developed in the academia. Now we need someone to do that in-between job, which are the startups where you start and you take it to a level where you do a pilot, and then you come to the commercialization space. So today, I believe that in India, we are at a very interesting juncture where you have, DST, DBT, BIRAC, there's a statutory body called BIRAC, and there are many other organizations which are supporting the startup in the initial stages. And then comes the Technology Development Board, which is into the commercialization space. So I'll give, in next 10 to 15 minutes, I'll run through the presentation, and after that, I'm available for me and my colleague are available here for whatever questions you have, whatever clarifications you have. And even if that doesn't work, you can always write to us, we'll get back to you. So I'll start the presentation, and it will be covered under the following heads: brief background, mandate, funding process. Why I wanted to come to the funding processes, so that the industry is here who understands what are the process, and it is not difficult for you to communicate with us. Even if it is, we are open, you can always call us. My number will be there. And what we have done, so that, we have been in existence from last 25 years, and we have done some phenomenal work. So it's not that only I am saying it's phenomenal, I'll tell you what projects we have funded so that you can decide on your own. So TDB is a statutory body which was constituted in 1996. It's a unique government body. I do not think there's any other government body which is into funding of commercialization technologies. Now, as per the Act, as you can see, provide financial assistance to industry concerns and other agencies attempting commercial application of indigenous technologies or adapting imported technologies. So when I say adaptation of imported technologies, I'm talking about a value addition to that cause. It's not just a technology transfer which has come to India and then we can fund it. So that does not fall into our mandate. Basic R&D does not fall into our mandate. But the commercialization of the R&D which you have done, that comes to us. Now the objectives, we fund companies even at the risk of failure. Because the technologies which are coming for the first time, most of the banks, even like when I talk about some success stories, one of them I would talk about is a company called Santa Biotech, which was into biotech space, which created the first hepatitis B vaccine in India. Right, when the founder of the company, Mr. K.I. Varaprasad Reddy, went to the bank, so bank just said that there's no demand. He said there's no demand because it's not being manufactured. And by that one company, when we funded it, the price of that, hepatitis B vaccine dropped down from $23 to $1. With that $1, it was available to every Indian citizen, and not only that, it was available to entire world after that. The price dropped over the world, so everyone could, get the benefits of the technology which was developed in India. Now I'll come to the funding process. Why? Because this is where the crux for the industry lies. We provide up to 50% of the project cost at 5% simple interest. So if there's a project, like when I just heard about Northeast, somebody like, we also have a focus area in Northeast right now. But if somebody wants to set up an industry in Northeast, what you need is the capital. Let's say for 2 years, you have to set up that plant. So we provide funds. And for those 2 years, we do not charge you anything. It's only the interest, 5% interest, which is getting accrued. You don't have to return the money to us. Beyond that, 1 year is a moratorium period. And then 4.5 years, 6 monthly installment, the money has to be returned to us. I think it is even lesser than the inflation. The royalty rate is, as of today, is 0.5% of the sales turnover of the product once you commercialize it. Right? At times people feel, my sales will be much higher and 0.5% will work out to be much bigger amount than what I'm envisaging today. But in that case, you can always, pay us back and close the loan. So it is only during the currency of the loan, not beyond that. And funds are released on tranche basis. So there will be milestone attached to it, and once you achieve that milestones, then we release the funds. Now this is the most important part where I'll come to, which is called Initial Screening Committee and the Project Evaluation Committee. So how do we evaluate a project? So it is like, if I have a project in, like I was talking about polymer science, so I'll have someone who's been working on that sector. Coming from the DST, we have access to people who are working in IITs, CPETs. So if there's a project which is coming onto a certain sector, like when we have during the COVID, we have some RT-PCR kit which has to be tested, right? Technology has to be evaluated. So we'll have someone from ICMR looking at it. So it is not only that, we are only funding, we are also giving at the right time the feedback, the right questions, whether you have done the technology enough, is the technology robust enough? So before you get into the market, you are sure as you can be, that this is going to be successful. So our evaluation process has financial expert and technical experts both. The technical experts evaluate your technology, whether it's viable, whether it's working, it's scientifically right. And then you have the financial experts who's going to evaluate your business plan, your projections, your viability of the product. So that is how the project is evaluated. It is evaluated in two different committees. First is the Initial Screening Committee, which sees whether the project falls into a mandate or not. If it falls into a mandate, then it's a project evaluation where we go on site. And that is where the evaluation happens for the actual on-site evaluation. Now, we can fund under the following heads. You see land, site development, civil works, factory, administrative. So your entire capex, up to 50% of the project cost, we can fund. Over the years, we have signed more than 350 agreements, and our outlay has been around 2,200 crores, and we have leveraged from the industry around 800 crores. Sorry, 8,000 crores. We have funded across the sector. We have funded health, medical, engineering, information technology, but our biggest impact as of today has been into the health sector. Because if you talk about any big biotech company today, you talk about Ranbaxy, Cadila, Biocon, not Serum Institute, sorry, Biological E, Bharat Biotech. Bharat Biotech actually happened to be the second company after the Santa Biotech, which we funded in 1996. So you can imagine what they are today. But at that point of time when they came, we took the risk. It's the Government of India body, the Technology Development Board, which took the risk to fund those companies, which at that point of time, people in the West thought कि India में कुछ बन भी सकता है क्या, especially in the biotech sector. So from there, today we have come to a space where we are the pharmacy of the world. And within 1 year of COVID, we have been able to develop an indigenous vaccine. And just on another short note, out of 7 COVID vaccine manufacturers in India, 6 have been funded by us at certain point of time. And not today, when they were in the initial stages. And the 7th one, Serum Institute of India, their founder was on a board. Now these are some of the chemical industries I'm just talking about what we funded. But this is basically, if you see, when we talk about the next question which generally comes from the industry is the quantum of funding. Like I said, it's up to 50% of the project cost. We have funded companies from 7.5 lakhs to 250 crores of TDB contribution. So as of today, the Government of India has never denied us the money. If the project is good enough, we are willing to take it. Like I said, Bharat Biotech, Santa Biotech, global hospitals. So generally, I start my talk most of the times that, which I'm trying to end with, that what is the commonality between the first vaccine which was made in India, the first electric car made in India, the first indigenous car, that is Indica, made in India, the first liver transplant hospital made in India, the first RT-PCR kit made in India, the first 1,000 drone show. We have supported all of them financially. Thank you. I'm open to questions. I'm open for discussions. So I'll be more than happy for the for even the academia also to interact, because I feel at a certain point the kind of technologies which I've heard. My background happens to be the material science. I did my master's from IIT Kharagpur in material science and engineering. So when I see those technologies and see that in labs, I really feel, what are we doing? We have so much of potential. Why don't we go out and have a few startups looking at that? And there's so much of support available today. So I would really urge you, to find avenues that we can leverage what we have today. Thank you. Ma'am, please.
Where the scale is at pilot level, we can do. But the industry is also not willing to take it from that point. The gap between that scale, a lab like CSIR cannot do. So, will a government DST fund, because what happens is the capex, then who will own the capex? The problem with this one is that the capex then will be in the NCL scientist's name, which is...
which will not work actually.
Yes.
So I would suggest, that's why I was saying, if you have an industry coming in, 50% of the project cost at 5% simple interest makes it really viable, right? And yes, developing something on a pilot scale and taking it onto a commercialization scale does require industry intervention, because it's very difficult. It's not easy to be an entrepreneur today, but then there are benefits for it. So we can make it easier by giving a loan, but the loan will not be on the individual basis. It will always be on the company. So it has to be a private limited company for TDB, because otherwise it's a R&D. But commercialization is different. If there are no further questions, I'll leave. I'll finish.
I'm from Indian Rubber Manufacturers Research Association. That's a wonderful, awareness program which for the industry connect. We also have developed some of the, products which are getting commercial. In fact, one of the MSMEs, struggling to get financial funding. So maybe I will refer. We developed a, bio-based sealant for puncture resistance. Okay. In fact, even if it is running on a, nail vehicle, after that sealing, it doesn't, air continuously retained basically. So it's a good, wonderful technology. So he is struggling to get it, commercialized basically in a bigger scale basically. So I just heard that, like, is it a private limited or it could be even MSME, any kind of?
No, it's, see, when I say private limited means it just doesn't have to be LLP.
Okay.
Right, any company will be registered.
Okay.
We need a registered private limited company, that's all. And it can be any sector. We are not, we are sector agnostic from agriculture to aerospace. We have funded nearly everything. And I would be more than happy if you can spread a word around, because, see, we also look for good projects. We also want success stories to be coming on. That will also make the, India more Atmanirbhar. Like recently we have funded companies which have been, for the first time in India, somebody has developed a quantum key. And I think it's the only company in the Asian region that has a quantum key distribution which has already tested for around more than 200 kilometers. Officially, they have not told me, but unofficially, that's what the figure today is. So there's a lot of good, even in space we are funding. So I would be more than happy, and material science, is close to my heart. So definitely I would want to have more companies coming there. Thank you.
Thank you so much, Mr. Kaushik. I hope all these facts and aid help us reach new heights in the sector of science and technology. And now we would like to wrap up this conclave with the last presentation on plastic park scheme and its benefit. For the same, I request Mr. R.K. Soni, Director DCPC, to join us on the dais.
Respected Madam, dignitaries high in the hall, in addition to 13 COE, the Department of Chemical and Petrochemical have set up 10 plastic parks. So let me share what is the plastic park and where these plastic parks are set up. So with the scheme of setting up a plastic park is a cluster development approach which have different type of facilities, and plastic parks are developed by the state government, and we, the government of India, support some financing up to the 50% of the project cost, selling to the 40 crore rupees per project. The main feature of the plastic park is the CFC, where the unit can test and prototype, virtualization, non-destructive material testing, and these CFCs are maintained and operated by the CPET. These are some benefits that someone set up their unit in the plastic park. So they can get the raw material near to the plastic park, and in the two plastic parks they get raw material at discount rate also. The state government also gives some relaxation in taxes, provide electricity at yes, subsidized rate, and these rates are vary from state to state. So now let us see the location of the plastic park. So this is the first plastic park near to the Bhopal in the village of Tamot. This plastic park is around 25 kilometers from the Bhopal, and this plastic park is developed in the 122 acre of land and have the 155 plots. Apart from these photographs, we have some video also. So let me show you the video also.
Welcome to the City of Lakes, India's cleanest capital city, Bhopal. Madhya Pradesh is one of the fastest growing state and investment destination. Being situated in the heart of India, the location advantage is unmatched. Bhopal, plastic park developed by Madhya Pradesh Industrial Development Corporation Limited, MPIDC, a government of Madhya Pradesh corporation entrusted with the responsibility of industrial promotion through development of industrial growth centers. Plastic Park Tamot is being developed to boost manufacturing in polymers and plastics under the scheme of Ministry of Chemicals and Fertilizers, Government of India. Plastic Park Tamot is situated at Village Tamot, Tehsil Goharganj, District Raisen, on National Highway 12. The site is a 30-minute drive from Bhopal and 15 minutes from Mandideep industrial area. It has direct rail link with inland container depot at Mandideep, situated 17 kilometers away. Built in an area of about 50 hectares, the park boasts of excellent industrial infrastructure like 7-meter wide cement concrete approach and internal road network. Dedicated power supply from 132 kV and 33 kV substation, storm water drainage, street lighting, etc. In addition, following common facilities are available to supplement production. Advanced Plastics Product Simulation and Evaluation Center, APPSEC, for simulation and evaluation support, prototyping, incubation center, training and skill development. The APPSEC is functioning as satellite center for Central Institute of Plastic Engineering and Technology, CIPET, Bhopal. Skill development program and diploma courses have been started at Plastic Park, Tamod. Plastic waste recycling facility with an ability to handle 26 metric tons plastic waste per day is operational here. Common warehousing unit integrated with a packaging unit. Administrative complex with secretarial support and trade facilitation. Sewage treatment plant. Dedicated staff for maintenance of infrastructure and utilities. Units in Plastic Park Tamod have advantage of excellent industrial ecosystem that exists around due to its close proximity to industrial area Mandi Deep, 15 kilometers, which is home to 731 industries in textile, pharmaceutical, food processing, engineering, automobile, and other multiple sectors. Prominent industries in Mandi Deep include Bardhaman Yarns, HEG Limited, Procter & Gamble, Lupin Limited, Crompton Greaves Limited, Tafe Motors Limited, Dawat Foods Limited, Harshi India Private Limited, etc. MPIDC invites you to become a part of this journey towards growth and prosperity. Fully developed plots are ready for allotment on concessional rates with 99 years lease. Online allotment has been started.
So in the plastic park, out of 155 plot, around 17 plot have been allotted and 3 units are working there. Now this is the second plastic park in the Paradip, Odisha. This plastic park is also developed in the 120 acre of land and have 80 plots are there. And someone suppose set up their unit, the IOCL offer the raw material with a discount of rupees 2,000 per metric ton. For more details, we have given the detail also. This is the third plastic park in the Tinsukia, near the Dibrugarh. From Dibrugarh, it is around 35 kilometers, and this plastic park is also developed in the 173 acre of land and have the 104 plots. They can also get the shared on the rent also, and the BCPL from the Dibrugarh also offered the raw metal on the discount of rupees 1250 metric ton. This is the fourth plastic park in the Bilova near the Gwalior, and almost 70% work have been completed. The park is being developed in the 93 acre of land and 107 plots are there, and 3 plots have been allotted there also. This is the fifth plastic park in the Jharkhand near the Devgarh, and the development of the plastic park in progress, and more than 50% work completed. This is the Thiruvallur plastic park near Chennai. This is around 30 kilometers from the city center of the Chennai, and the park is being developed in the 257 acre of land and have the 65 number of plots. This is the seventh plastic park in the Sitarganj, Uttarakhand, and the work is in the progress. And this plastic park will be in 40 acres of the land and have the 77 plots. This is the new plastic park which have been approved recently. This plastic park is in the Raipur, near the city of the Raipur. I think 8 kilometers from the heart of the Raipur. So this will be developed in 47 acres of the land and will have the 55 plots. This is the new plastic park which have been approved recently near the Bengaluru. The location of the plastic park is 20 kilometers from the Bengaluru and will have the 53 plots. This is the 10th plastic park approved in the Gorakhpur, and the location of the plastic park is around 7 kilometers from the city. And this plastic park will also will be developed in 88 acres of land and will have the 92 plots. Thank you.
Thank you so much, everybody, for joining us. This conclave wouldn't have been a successful one without your presence and, of course, lots of valuable knowledge that you brought on the table today. So I present my gratitude before you all leave, and we hope that from this day onwards, we start working on our agenda and the plan of actions we discussed today. And finally, to conclude this session, I request DCPC to join us on the dais.
Thank you. And now we are at the end of this conclave, which is just a start of a new era. And today is in this particular Industry Connect conclave, where our all 13 COE, they got an opportunity to showcase their finding, their outcome, what are the new things they are coming up with the indigenous technology, indigenous research, and that is purely in line with our Honorable Prime Minister's vision, the Atmanirbhar Bharat. Whether we talk about the various technical things like electronic waste, women hygiene, high solid content, coating, whether it is a non-isocyanate, petrochemical aspects. So all these things they have, our COE colleagues, they have discussed in a very wide spectrum. And since I was also associated with the one of the COE at IIT Roorkee, so we usually find that this we should get some opportunity to showcase our finding with our industrial partners, so that the commercialization, because without the commercialization, any kind of the technology development, any kind of things is of no use. So keeping in view of this thing, fortunately our secretary madam, she instigated this particular idea that why we are not inviting the industry people to showcase our thing, that we are funding so many things in the aspect. Let us make them a partner for this journey of this Atmanirbhar Bharat. So keeping in view of this particular aspect, this particular idea was conceived. And based on the very short span of time, we fortunate enough that our various industry colleagues, they from across country, they came forward and they joined hand with the COE people. Now, I will not say that this is the end of this conclave. Let us say that this is the beginning of the thing that which we are planned, and the journey will go on with the help of industry partners, with the help of the COE, with the help of academicians, with the help of the researchers. And particularly, the basic motto is that we should go for the Atmanirbhar Bharat. And in the morning I said that this Atmanirbhar with Atmavishwas. So when our COE will showcase all these kind of findings, definitely the industry will come with the concept of Atmavishwas. So with these words, I'm hopeful that this journey will go on and we will get the support from the industry in future. Thank you very much.
As precisely mentioned by Sir, this conclave might come to an end here, but this will be the beginning of continuous interaction between industry and the academia. So before concluding this conclave, we would like to thank Madam Aarti Ahuja ji, who was with us throughout the session despite of a busy schedule. And once again, thank you to all the COE representatives and the industry representatives. Thank you one and all. You all are requested to join us outside for the high day. Thank you so much and a very good evening to all of you.